In the throes of her sinking, Titanic's funnels come crashing down. But what is it about their engineering that made it happen? In the wake of the Second World War, cargo and passenger ships mysteriously begin breaking in half, and it's up to engineers to try and figure out why. Germany builds some of the greatest passenger liners of all time, but soon they're taken away. In the 1960s, survivors of the Titanic disaster watch the movies and react to Hollywood's earliest depictions of the tragedy. The magnificent SS Strathnaver heralds a new age for P&O Line as they struggle in an increasingly competitive industry. And finally, cameramen capture some of the most dramatic events as real ships sink on film. Ladies and gentlemen, I'm your friend Mike Brady from Oceanliner Designs, and this is 3 hours of good old-fashioned ship history. On the morning of April 15th, 1912, at around 2:15 AM, the end had come for RMS Titanic. As passengers and crew struggled around the base of the number 1 funnel to free and fill the lifeboats there, the ship took a dive down by the head and a wave washed up the boat deck. Suddenly, the desperate crowd was presented with a fresh misery. The forward funnel, the height of a 5-story building, came crashing down on their heads. Today, we're all familiar with the sight of Titanic's funnels. The 4 black and buff-coloured smokestacks have become something of an icon synonymous with the great ship itself. But what were they made of? How did they work, and why did they collapse as the ship sank? Other ships of the time sank, like Lusitania, and their funnels stayed in place until they hit the sea floor. What was it about Titanics that made them come down? Today, we'll analyse the funnels, how they were made, how they worked, and the forces at play that caused them to fall. To understand why Titanic had 4 funnels at all, and why they were so big, we need to delve a little bit into the history behind these things. And don't worry, I promise you, it's an interesting story. In the early days of steam, ships carried 1 or 2 small boilers to generate the steam, so only a single chimney-styled smokestack was required. But then, as vessels grew in size and complexity, the number of horsepower required to move each ship increased, and so did the number of boilers. The earliest steamships had 1 or maybe 2 funnels, but in 1859, a new ship set to sea with no fewer than 5 of the things. There was a good reason for this. The SS Great Eastern was ridiculously big. In 1857, the biggest ship in the world was a steamer called Adriatic, which was about 354 feet, or 108 metres long, and 3,670 gross registered tons. And then a year later, Great Eastern was launched at 692 feet, that's 211 metres long, and 18,915 gross registered tons. Now that is a ridiculous jump in size. The ship was the brainchild of the revolutionary engineer Isambard Brunel, a legend and industrialist, and his ship, which he nicknamed his Great Babe, was an absolute outlier. Moving a ship that large through the water needed a similarly immense amount of horsepower. She was fitted with 4 steam engines for the paddles, and another for her propeller, giving her an impressive speed of 14 knots. That's 26 kilometers per hour, or 16 miles per hour. It was more than just impressive engineering for the time. It was achieved by supplying Great Eastern's engines with a monumental amount of coal and boilers to burn it and make the steam. The result was a then unheard of amount of 10 massive boilers producing both the required steam and a heap of thick, black, acrid coal smoke. Now, venting this up and out of the ship was the job of the funnels, and the larger number of boilers simply meant there needed to be more funnels to deal with the smoke. The 10 boilers were each paired to a funnel, resulting in the impressive array of 5 thin smokestacks, each one tall enough to ensure the worst of the smoke would pass harmlessly over passengers' heads on deck. Now, this ship is nothing short of an engineering marvel, but at the time, Great Eastern was actually mocked for its then ridiculous size and also for the number of funnels that it carried. It was just 50 or 60 years ahead of its time, and Brunel would have the last laugh because decades later, in the 1890s, German shipbuilders used essentially the same layout to create the blueprint for the world's first 4-funneled liner, the Kaiser Wilhelm der Grosse. Now, obviously this was to do with the number of boilers and the speed that the ship needed to hit, but it caused a sensation with its 4 huge smokestacks, and carrying that many funnels became de rigueur for the most prestigious passenger ships on the Atlantic. Cunard Line were quick to follow up a few years later with their own pair of 4-funnelled superliners, Lusitania and Mauritania, and then it was White Star Line's turn. Now we understand why Titanic had 4 funnels. It was clearly to do with the arrangement and the layout of the boilers. The first 3 funnels were coupled to boilers and dealt with the smoke and fumes, but there's actually been a bit of a myth surrounding the 4th funnel, that it was just a dummy, only added for looks. If we cut Titanic down the middle, you can see that the 4th funnel really does sit over a part of the ship dense with machinery, the turbine engine room. Other ships of the day, like Kaiser Wilhelm der Grosse, provided deep shafts to ventilate the engine rooms and provide an exit for warm air. Titanic had one just like it over her main engine room too. But there was a peculiarity in Titanic's design that made her different to other ships. She had a 3rd engine, a steam turbine that was different to her main engines. It needed its own ventilation as well. Now, White Star could have just installed another shaft or a dense pack of ventilators designed to draw in fresh air, but obviously that wouldn't work with the ship's balance, so the inclusion of a funnel as a ventilator here was, in that sense, for aesthetics. But the 4th funnel also vented smoke from 2 different key areas. The fireplace and the first-class smoking room here, but more crucially the massive galleys for the various dining saloons. That smoke from the ovens too needed to be lifted high over the heads of passengers, and the 4th funnel did the job. We'll have a closer look at how they did so shortly, but that was a brief explanation of how and why Titanic got her 4 funnels. Now, funnels also performed a secondary job of marketing their owners. A ship's funnels are arguably the vessel's most identifiable feature, and this was especially true in Titanic's era, when they were proudly painted in their company's colours. Now, it was an easy marketing opportunity, and paint schemes of all sorts were applied to make the company's fleet stand out. But even this idea was a relatively new one. Smokestacks hadn't even really been around that long because steamships had only become widespread some 50 or 60 years earlier in the mid-1800s. Early on, the stacks were usually painted black to hide the soot from all the thick coal smoke that was spewing out of them, but then something changed. One of the early steamship adopters was the famous Cunard Line, and their bright vermilion funnels and black bands soon became an icon of the transatlantic trade. Funnels, as we'll soon explore in more detail, are extremely hot, and they're made of very thin metal, so they need to be protected against corrosion and damage. In the early days of the steamship, engineer Robert Napier was grappling with the issue of painting a funnel. Regular paint would flake right off because of the heat. He patented a special mixture of buttermilk and red ochre, a weird mix that actually worked brilliantly because the heat of the funnel would then self-bake the concoction on and therefore make it stronger and more resilient. It resulted in a bright orange-red colour that soon was passed on to his business partner, a man named Samuel Cunard, who adopted it for his ships. The colour soon became known as Cunard Red, and the concept of brand recognition through the steamship's funnel colours was cemented. The idea took off as more and more steamship companies were founded and wanted to identify their ships from the pack. Cunard Line's great rival, the White Star Line, adopted their own recognisable colour scheme, a colour known as White Star Buff that was somewhere between a warm yellow and a light tan brown with a black top for the soot. Titanic carried those 4 immense funnels, each painted in the immediately recognisable White Star Buff paint scheme. So now we know the history behind why Titanic had so many funnels and why they looked the way they did. We need to deep dive into some engineering behind their function because this gives us some clues as to why they might have failed on the night of the sinking. Well, it turns out that Titanic's funnels, as viewed from the outside, were, if you'll forgive the pun, just the tip of the iceberg. The entire structure was complex and ran deep into the bowels of the ship. We'll start down here in the boiler rooms where coal is burnt to boil water and generate huge amounts of steam. The steam is vented under pressure into the engines, but the excess smoke from the burning coal has nowhere to go. We already knew that. The Titanic's funnels served to vent the gases and the smoke, but they also helped the boilers burn hotter in the first place and more efficiently, purely because of their massive size. Now, we've covered this already in more detail in our video outlining the workings of Titanic's engines, but essentially, a fire needs oxygen to burn well, and getting oxygen into the bottom of a ship 10 stories below the upper deck is something of a challenge. Titanic used large fans called stokehold fans to suck in gallons of air from above and feed it directly into the boiler rooms themselves. They didn't feed the fires in the boilers directly. Instead, the boiler furnaces would draw the air in around them, meaning the fresh air also helped to keep the room itself and the poor workers somewhat cool. Temperatures could still reach the high 40s in Celsius. That's between 110 and 120 Fahrenheit, but it was better than nothing. The fire in the boilers needed a draft to help suck in the fresh air and burn hotter, and this is where the funnels came in. It was actually all a simple mathematical equation. That many furnaces, and Titanic had 159 of them, needed a certain amount of oxygen for the most efficient burn, and this dictated the size of the funnel's internal flue. It worked just like the chimney of a house, but on an enormous scale. The internal flue size was guided by the amount of area that was needed to provide the optimum draft for burning in the furnaces. It's why old steamships' funnels were so big and tall. In fact, some were ridiculously so, like the poor old USS Helena here of 1897. So now we know the boilers are burning the coal and being fed a lot of fresh air, but all that soot and smoke generated from the furnaces has to go somewhere, and this is where the uptakes come in. Boiler uptakes were elaborate, branched structures made up of thin, riveted steel plates. Each branch connected to a boiler's smoke box and received the soot, the smoke, and the gases directly from the boiler's furnaces. A complex system of internal baffle plates channeled the smoke by creating a draft and ensuring it was heading with force in the same direction at all times. The uptakes, and it cannot be stressed enough, were huge, and so was the amount of smoke pouring through them. As such, a huge chimney was needed to vent this well out of the ship, and here is where the first funnel structure actually comes into play, the lower funnel, spanning the top of the uptakes to the top of the boiler casings. Now the lower funnels were fairly complex in their own right, but suffice it to say they acted as a flue and were split on the inside into sections to ensure optimum draft, even if one of the connected boiler rooms was non-operational at the time. The lower funnels would have been extremely hot to the touch. The gases being vented through them reached about 315 degrees Celsius or 599 degrees Fahrenheit, so they were encased for their entire height by boiler casings, which shielded the public spaces from all that heat. This is why the interiors of Titanic featured the occasional odd rectangular structure right in the middle of large public rooms. They were well decorated, so you probably wouldn't really notice them, but they were really the boiler casings which housed the uptakes and the lower funnel, like this one down here on D-deck in the first class dining saloon and reception room, and this one here from the first class smoking room. Inside the casings, insulation like cotton silicate or cork slabs between 1.5 to 2 inches thick, that's about 5 centimeters, provided some insulation against the great heat. The lower funnels rose to the height of the boat deck houses at the top of the ship, and connected to this structure is the one we all know and love, the upper funnel, each some 60-odd feet tall. In fact, to account for the ship's shear, that is, the amount that it sagged in the middle, each funnel was a different height, the two tallest being numbers 2 and 3, so that from afar they would all look to actually be the same height. The funnels were actually deceptively complex in their internal layout, while also being extremely fragile in their construction. In the early days of steam, funnels had basically just been large chimneys that vented the smoke out and were extremely hot to the touch. Remember Napier's paint formula that actually baked itself onto the steel? Well, by Titanic's day, things had changed somewhat. To prevent burns, the funnel was made to be a double-walled structure made of riveted metal plates. Putting some distance between the inner and outer walls would mean the hot gases inside wouldn't heat the outside up as much as it might otherwise. The funnels were built as one piece in the Harland & Wolff shops, winched up onto massive cars, and then trundled out to Titanic as she waited at the fitting out wharf. They were craned up one by one, and then riveted to the ship's deck plates. We'll get to that in a minute. The inner structure was connected directly to the lower funnel, and took in the gases being vented from them and the uptakes. It was spaced apart from the outer structure by metal plates to ensure that the exterior of the funnel would not run as hot, and then to make sure the funnels retained their shape, they were reinforced with bands and stiffening rods at their tops to keep their elliptical cross-section. The funnels were made to be as lightweight but strong as possible. The ship was expected to rock and roll all over the place in bad weather, and those funnels would have to hold on for dear life. If they were built too heavy or over-engineered, no amount of bracing wires or reinforcement would hold them in place because they were each the height of a 5-story building. The steel plating used to make them was fairly robust, up to a half-inch thick, that's about 13 millimeters, but when you consider the thing was as tall as an apartment block, you realise they actually weren't too heavy-duty at all. In fact, this unique footage shows the Cunard liner Berengaria of Titanic's vintage being scrapped in the 1930s, and watch what happens when the funnels lose their support wires and are brought down on the deck. The internal bracing and stiffening rods which have held them in shape for 2 decades are overcome, and the funnel flattens out like a pancake. Now, being this delicate and also being extremely tall, the funnels needed some good support to stay mounted to the constantly pitching and rolling ship, which was no easy task. Just imagine the amount of strain they'd be under in a storm. The funnels were connected to the ship's decks by 2 means. First, the very bottom of the upper funnel structure featured a flange, which was riveted directly to the deck plates. But this alone wouldn't hold the funnels in place. They needed to be supported all around to keep them upright. Now this was the job of the stays and shrouds, galvanized steel wire rope 1 1/4 inch or 3.17 centimeters thick, connected to the funnel's tops with shackles along one of those stiffening bands designed to help maintain the funnel's shape. We mentioned earlier that the funnels were double-walled to prevent excess heat, but despite this, believe it or not, when under steam, the funnels would actually lengthen because of how hot it was. There had to be allowance for the strain. Now, because of this, the shrouds or cables couldn't be connected directly to the deck because they might snap under the pressure as the funnels became increasingly taller, even if only by inches or mere centimeters. To help with this, thick hemp rope, a lanyard, was woven around the shroud cables, and that was attached to pad eyes or shackles on the deck. This way the tension could actually be controlled. In fact, before lighting the boilers on departure, the funnel's shrouds would be actually slackened off by the crews at their lanyard so that the funnels could increase in size and the strain would be eased. The funnels were also a convenient place to mount other important pieces of equipment. Naturally, the ship's huge sets of whistles sat proudly on a platform towards the funnel's tops. Each funnel actually had its own set of these tri-bell type steam whistles, but only the forward 2 sets actually functioned. Forward and abaft or behind the funnels were mounted tall waste steam pipes which could be used to vent excess steam out of the boilers if the engines were stopped or if too much steam was being generated. Because the funnels provided a nice, tall surface, various water pipes could be fitted to them too. You can see them in photos. The U-shaped piping runs up about half the height. This means that the water system for the ship's taps was provided with a natural pressure from the gravity afforded by mounting the pipes to the tall funnels. So now we well know what Titanic's funnels were made out of, how they functioned, and how they were attached to the ship. But on the night of the sinking, something very strange happened. Those carefully engineered structures came crashing dramatically down. Something had gone horribly wrong. At about 2:15 AM, all hell had broken loose on the roof of the officers' quarters underneath the ship's first funnel. Second Officer Charles Lightoller was working with a group of sailors to prepare an Engelhardt collapsible lifeboat for lowering when the ship sank out from underneath his feet with an alarming plunge. It sent a wave rolling up the boat deck, knocking people over and sucking Lightoller down, pinning him up against a ventilator's grating as water rushed in to fill the empty void below. Lightoller was eventually blasted off by a rush of hot air and came to the surface near the collapsible boat that he'd tried to help free. It had floated clean off the deck as the ship sank. He explained himself what happened next at the inquiry when he said, "I just held onto something, a piece of rope or something, and was there for a little while, and then the forward funnel fell down. It fell within 3 or 4 inches of the boat. It lifted the boat bodily and threw her about 20 feet clear of the ship, as near as I could judge." Now that was an incredible near miss, and extremely fortunate for those who were clinging onto the boat for dear life, but others were not so lucky. Dick Norris Williams was a rising tennis star travelling with his father in first class. They were both swept into the water by the downwards plunge too, and Richard caught sight of his father swimming towards him. He later wrote, "I saw one of the 4 great funnels come crashing down on top of him. Just for one instant I stood there transfixed, not because it had only missed me by a few feet. Curiously enough, not because it had killed my father, for whom I had a far more than normal feeling of love and attachment, but there I was transfixed, wondering at the enormous size of this funnel, still belching smoke. It seemed to me that 2 cars could have been driven through it side by side. As the funnels came down, we can assume they flattened out now that the bracing was overcome, just as we saw in that footage of Berengaria's scrapping. Even worse was to come though. With the funnels down and detached from their seatings on the deck, a gaping maw was left behind, where, according to passenger Eugene Daly, people were sucked in by a torrent of water like flies. It's very grim stuff. As if the ship's sinking wasn't already bad enough, the collapsing funnels, and by the way, number 2 went down soon after number 1 did in a shower of sparks and soot, took quite a few people with them. So what had happened? These funnels were designed to weather the worst of the Atlantic storms, the heavy pitching and rolling in huge seas. They were lightly built, heavily braced and reinforced, but still they had failed. Lightoller presented his own theory at the inquiries when he said, "The terrific strain of bringing the after end of that huge hull clear out of the water caused the expansion joint abaft number 1 funnel to open up. The fact that the 2 wire stays to this funnel on the after part led over and abaft the expansion joint threw on them an extraordinary strain, eventually carrying away the port wire guy to be followed almost immediately by the starboard one. Instantly the port one parted, the funnel started to fall, but the fact that the starboard one held on a moment or 2 longer gave this huge structure a pull to that side of the ship." Titanic had 2 big expansion joints for her upper decks. Bridges actually use these today for similar reasons. Essentially, large structures tend to bend and sag, or lengthen and shorten depending on conditions. For a ship like Titanic, her hull was designed to hog and sag to some extent over big waves. If built too stiffly, it would simply break apart in a heavy sea because there was no easing of the strain. The superstructure on top of Titanic wasn't part of the hull, it was simply attached and would be expected to bend and sag along with it. To help it do this without tearing any of the steel plating that made it up, expansion joints were fitted, breaks in the structure that were separated by a short distance. In passenger spaces, the joint was covered with brass and leather to hide it or at least make it barely noticeable, but with the expansion joints fitted, the superstructure could now flex with the ship's hull. And as Lightoller noted, the immense strain of the sinking was causing Titanic's hull and superstructure atop it to hog. That is, bend downwards, thanks to the effects of gravity pushing the stern down as it was rising higher through the sinking. With the expansion joints opened up, the stays, or support cables which supported the after part of the funnel, were on the other side of the expansion joint, and his theory suggests that they were suddenly under huge strain and that they failed. But the question has to be asked though, was the parting of those stays the cause of the collapse, or just a symptom? See, Titanic's funnel stays and shrouds were designed to withstand a huge amount of pressure. On the transatlantic run, heavy seas and rolling waves could cause a ship to roll and list either 10, 15, or 20 degrees or more. Now, this type of experience was commonplace, and ship design had to take it into account. It's worth remembering that Olympic, throughout her entire career, in rough seas and storms, never lost a funnel. And it's hard to imagine that Harland and Wolff designed the funnels such that the parting of 1 or 2 stays could ever possibly cause a collapse in the first place. In fact, the last 2 funnels on Titanic remained in place high up in the air. Funnel number 3 had a pair of stays that crossed over an after expansion joint as well, but that funnel remained in place until the ship broke apart underneath it. It shed some doubt on Lightoller's theory. If it was just the effects of gravity and the opened expansion joints at play, shouldn't all 4 funnels have come down at the same time? Well, the timing of the funnel's collapse actually gives us our first major clue as to what was actually happening. Funnel number 1 collapsed when water, roaring up the boat deck, met its base, and then number 2 did the same thing. Clearly, the water was having some effect, but what? At the British inquiry into the disaster, naval architect Edward Wilding, who'd actually helped design the ship, gave his opinion when he said, "The funnels are carried from the casings in the way of the comparatively light upper decks, that is the boat and the A deck. When these decks became submerged and the water got inside those houses, the water would rise outside much faster than inside, and the excessive pressure on the comparatively light casings, which are not made to take a pressure of that kind, would cause the casing to collapse, would take the seating out from under the funnel and bring the funnel down." Now, water pressure is capable of terrifying things, as anybody familiar with the effects of delta P can testify. 1 foot of water pressure equates to roughly 3.06 kilopascals, or less than half a pound per square inch. But as water rushed up the funnel's base as the bow sank, the pressure increased dramatically. At 10 feet, the funnel's base would have been under some 30.6 kilopascals, or 4.4 psi of pressure, and the casings and deckhouses down on A deck would now be under 92 kilopascals, or 13 psi of pressure. Now, what Wilding was suggesting was that the lower funnels and the casings were buckled by the water pressure, and this brought the funnel down too. But the evidence from the wreck suggests otherwise, because the casings and the lower funnel are still all there in fine shape. It seems more likely that water rushing up the boat deck surged around the base of number 1 funnel, and then the pressure began to mount. We know the funnel collapsed sometime after Lightoller surfaced nearby, meaning that the funnel would have had to have sunk for a while and its base would have been at quite a depth when it came down. Perhaps it was as deep as 20 feet or 6 meters. With the entire interior of that funnel, the lower funnel and the casings not yet flooded and now under extreme pressures, a structural failure would have been inescapable. It's not implausible to think that water pressure began to buckle the base of Titanic's forward funnels, because at 25 feet of depth, the funnel's base would have been under around 11 psi, or 74.5 kilopascals. As the base buckled and the funnel began to topple, excess pressure on the shrouds and the stays would have caused them to snap. To those in the water outside, like Lightoller, it might have looked as if the shrouds and the stays were straining and snapping, causing the funnel to fall, but it was actually the other way around. 11 psi doesn't sound like a lot, but acting on something as big, hollow, and lightly built as Titanic's funnels, it seems likely that the ocean's pressure at that depth could have brought them down. We know the water pressure was enough to collapse the grand staircase dome cover directly behind the number 1 funnel almost as soon as it was immersed in water, for example. Today on the wreck, there's no structure there at all, just an open hole where it once sat. Another clue to the water pressure hypothesis is the fate of funnels 3 and 4, which remained attached comfortably, high and dry, despite that ridiculous 20 to 30 degree angle down and the same list to the side that the forward funnels had endured. These funnels only detached during the breakup, when the forces of gravity became simply far too much for the structures to endure. Other ships from Titanic's era sank with surprising results. In 1916, Titanic's sister ship Britannic sank after striking a mine off Kea in Greece, and the result was very similar. Like Titanic, her funnels seemed to collapse one by one in turn, with survivor Corporal J. Waugh stating that as each funnel touched the water, it was torn off just like paper. Curiously though, just a year prior, the liner RMS Lusitania had sunk too, but her funnels remained attached as they were pulled underwater. Surely they must have been under similar forces as Titanic and Britannic's. Well, even though she was some 10,000 tons smaller than Titanic, Lusitania's funnels were even taller. But interestingly, they were actually braced with double sets of shrouds and stays at 2 different levels compared to Titanic's 1. If the bases of Lusitania's funnels began to crumple and fail, it could be that the much greater number of support cables was able to take up the strain and keep them in place. On top of that, differences in the makeup of the funnels, the plating thickness, the amount of stiffeners and internal reinforcement, it all might have meant that Titanic and Britannic's funnel designs were just more susceptible to failing and collapsing once subjected to water pressures than Lusitania's ever were. That's not a fault on the part of the designers though. No ship's funnel would ever need to endure that kind of punishment in normal life. Titanic's funnels are an incredibly iconic part of the ship's exterior, so much so that just the sight of any 4-funneled ship will invariably bring up the story of Titanic. Show your regular person a photograph of Aquitania, and chances are they'll call it Titanic. The number and size of a ship's funnels rose to symbolize that vessel's size and power, but in time they fell out of favor, possibly thanks to the Titanic disaster in part, but mostly due to changing tastes. In the 1920s, ships' funnels became smaller and more streamlined. There's just something so Victorian and industrial about the tall, straight funnels of Titanic's day, almost exactly like a factory chimney. As Art Deco took hold, ships' funnels shrank in size and became more shapely thanks to liners like Germany's Bremen and the USA's SS America. Today, ships still have funnels, but they're almost more of an afterthought. Ships aren't packed with dozens of boilers anymore, only diesel engines, meaning a single funnel is usually enough to do the job. Few could be considered iconic, save maybe for that of the Queen Mary 2, whose funnel shape was designed specifically to be short enough to fit under the Verrazano Narrows Bridge in New York, while featuring a large wind scoop to make sure that the smoke lifts high over the heads of the ship's passengers. I shot this footage myself last year, and I can tell you from experience that it definitely works. In a fitting touch, the funnel of this ship, the last and the largest ocean liner ever built, is finished in a variation of Cunard red, the same colour that Napier had developed all the way back in the early 1800s. Today on the wreck of Titanic, there is very little sign of those once proud and towering funnels. They broke free of the ship, but their shrouds and stays remained attached, causing havoc as they ripped up and down the deck, those 1 1/4 inch, 3.17 centimetre thick cables tearing lifeboat davits and equipment clean off the decks. The funnels themselves likely flattened out as they hit the water, like we saw with Berengaria's. Now, there only remains are some nearly unrecognisable piles of tangled plating and pipes on the ocean floor. It's hard to believe these majestic things once towered high over the ocean in the days when Titanic was the newest, finest ship in the world. The 16th of January 1943. It's a calm day at the Swan Island shipyard in Portland, Oregon. The brand new SS Schenectady lies peacefully at her moorings, having made it back safely from her sea trials, and she now awaits preparations for war service. But all of a sudden, a deafening crack rings out across the shipyard, echoing as far as a mile away. Out of nowhere, and for seemingly no apparent reason, the Schenectady's hull has cleaved almost completely in half. The incredible shipbuilding effort undertaken by the Allies in World War II saw the creation of thousands of vessels. T2 tankers, Victory, and especially Liberty ships have gone down in history for a number of reasons, namely their integral contribution to the Allied victory of World War II, the incredible story of their creation en masse, but, on a rather less positive note, their early tendency to split in two. As if afflicted by some kind of curse, the Schenectady was far from the only war industry ship to meet a catastrophic end. But what added still further to the growing worry surrounding these ships' failures was the mystery of why they were breaking in half at all. With multiple ships having split apart without a clear apparent cause, something was evidently going very wrong, and would go on to teach lessons in shipbuilding that are still in use to this day. When the US joined the war, the Battle of the Atlantic had already been long raging, and the Allied forces were struggling to hold their own in what was effectively a war of tonnage. Merchant ships were being sunk by German U-boats at a staggering rate, persistently prowling the waters in search of their targets, and British shipyards simply couldn't build enough ships fast enough to replace those that were being lost. The situation was dire. In just a few months, from the beginning of March to the end of May 1941, 142 merchant ships were lost to U-boats. Without some kind of intervention, and fast, it looked like an Allied victory would inevitably slip out of reach. Cue the help of the United States. The pressing need for replacement ships set in motion the production of Liberty ships as part of the $350 million emergency shipbuilding program. Now, before this point, the established construction methods for ships like that were, frankly put, just way too slow to meet the incredible demands of wartime. Now, unlike the previous standard for riveted construction, the significant time pressures at play here required a more time-effective alternative: welding. The man behind this new approach to quick and efficient shipbuilding, the American industrialist Henry Kaiser, created the namesake Kaiser shipyards, which would go on to significantly outperform all other shipyards of the era in terms of sheer scale and speed of production. If you were to go and visit one of these shipyards on any given day during this time, you'd be met with a flurry of activity and noise. Workers in their overalls, helmets, and leather gloves, heaving their equipment with them as they dashed between workstations. It was something never seen before in shipbuilding history. A purpose-built assembly line, more like a car factory, run like clockwork and capable of churning out completed ships at unprecedented rates. But what's more, the switch from riveted construction to the use of welding, along with the urgent necessity of labour to help maintain production schedules, afforded an extensive workforce of comparatively unskilled workers the opportunity to add their own contribution to the war effort. Many of us are familiar with Rosie the Riveter, but the lesser-known Winnie or Wendy the Welder soon started appearing in various recruitment campaigns. Thousands joined the burgeoning workforce, even travelling from other parts of the US to do so, drawn by the promise of better wages, the learning of new skills, and the opportunity to do their bit. A significant number of the new welders on these shipyards were women or those from minority backgrounds. Never before had there been the same working opportunities available to so many. Unlike with riveting, which required more extensive training, welding was simpler and quicker to learn, with one new female welder quoted as saying it was just like sewing. Though it wasn't without its drawbacks. Working days were long, and the work itself was physically arduous and at times very dangerous. The War Shipping Administration was an agency set up to oversee the operations of civilian yards across the US, as well as coordinating with the British merchant bodies. They put into practice the construction of a suite of new ships, each designed to fill a crucial role in the war effort and be built quickly and cheaply. Victory ships were large cargo vessels that displaced around 15,000 tons. They could be up to 455 feet, 138.7 meters in length. Impressive vessels in and of themselves, but joining them on the stocks was a dazzling array of specialist tankers and vessels, chief among which were the T2 family of tankers, long, utilitarian ships designed to ferry petrol, diesel, and black crude oil across the Atlantic to power the ships, tanks, and trucks intended to land in France. But before the Victory ships, the real jewel in the crown of the emergency shipbuilding program were the Liberty ships. Incredibly, more than 2,700 Liberty ships were built across just 18 shipyards between 1941 and 1945. And by 1944, average construction times are said to have been around 42 days per ship, compared to a previous average production rate of around 245. In one remarkable instance, the Liberty ship SS Robert E. Peary was built in a record 5 days as part of a morale-boosting propaganda effort. Now, these ships and the people creating them were making the impossible possible. Capable of carrying over 10,000 tons of cargo and over 441 feet long, the Liberty ship was adapted from existing British plans and appealed in its relative cost-effectiveness and fast construction potential. They were originally designated EC2SC1, that is, emergency cargo between 400 to 450 feet, where S referred to their 2,500 horsepower triple expansion steam engine, and C1 their specific design. These utilitarian ships were, on the whole, a little outdated. They were slow, and according to many, they weren't much to look at, even earning the nickname Ugly Ducklings. But despite this, they'd play a crucial part in delivering weapons and supplies to Allied troops, providing a key lifeline that finally offered a way to counter the devastating effects of the U-boats. President Franklin D. Roosevelt stated that these ships would bring liberty to Europe, effectively coining the name that they would come to be referred to forever. They'd become a symbol of hope, strength, and resilience. But not all was well. Liberties had been designed for mass production. Now, it might seem immediately apparent that anything that's set up to be manufactured quickly, cheaply, and with the use of relatively unskilled workers should immediately raise a question of quality and durability, but so far at least everything seemed to have been going according to plan. But this was about to change. The first truly significant blow to this new surge in shipbuilding came in the form of the SS Schenectady, and she would certainly not be the last. While fractures of varying extents had previously been reported in a number of different ships, nothing as bad as this had ever happened before. The Schenectady was actually a T2 SE-A1, or a T2 tanker, effectively the tanker counterpart to Liberty ships, which was built by the Kaiser Shipbuilding Company, and the Schenectady was the first to be constructed at the new Swan Island shipyard. At around 523 feet long, though almost comically small in comparison to modern equivalents, these 6,000 horsepower tankers were both bigger and faster than the Liberties, capable of speeds around 15 knots, compared to the more sluggish 11 knots of the Liberty ship. Now, originally, these were intended to use steam turbines, but a shortage of the available machine tools necessary to make the gears meant that they would instead turn to turbo-electric propulsion. As with the Liberties, the workhorse T2 fuel tankers were a crucial asset to the war effort, delivering crude oil, petrol, and diesel to those fleets already out at sea, fuel that they were completely dependent on. As such, the Axis knew to target them. That meant that, just like the Liberty ships, speed was the name of the game when it came to the construction of these vessels, and production time for the T2 tankers was rapid, with 533 of them being built by the US from 1940 to 1945, courtesy of the United States Maritime Commission. The SS Schenectady's construction was completed ahead of schedule in December 1942, but then, not even 1 month later, without warning, she fractured almost completely in two while sitting still, moored at her fitting wharf. The water was calm, the weather was mild, there was no discernible reason why this had happened, and yet the sight of the vessel jackknifed where she stood in the fitting out berth, along with the immense noise that accompanied the split, was undeniable. Now this was unfortunately just the start of the problem. Later that year, a Liberty ship would befall a similar dramatic fate. The 422-foot, 7,176-ton SS John P. Gaines, named for the Army officer and politician John Pollard Gaines, had been built by the Oregon Shipbuilding Company and launched on 11th July 1943. On the night of November 24, 1943, around 100 miles off the Alaskan coast, she was busy undergoing her second voyage, setting out from Dutch Harbor in the Aleutian Islands, headed for Seattle. The North Atlantic was facing an increasingly rough winter with plummeting temperatures, powerful swells, and winds up to 100 knots. It was in just such a storm that the SS John P. Gaines would meet her fate. At around 10 p.m. ship's time, the crew of the vessel reported hearing sudden, loud cracking noises, loud enough to register even over the roar of the ongoing storm. Knowing it would be impossible to identify the source of the noise in the crushing darkness, they continued on, but then, at 2:41 a.m., when all but the watchmen were asleep, disaster struck. The waves, which had already been wreaking havoc on the ship, had only intensified as the night wore on. A surge struck the vessel, then another, causing her to bend dramatically, and then, with a terrible metallic grinding, the ship's hull was torn in two, the bow drifting away and sinking below the inky water. As it turned out, the initial noises heard aboard the ship had been the beginnings of a port-side fracture from the number 3 cargo hatch. The repeated forces of the waves caused the break to propagate out towards the deck and ultimately tore it apart. Luckily, due to the effective warning bell that the early noise had signalled, those on board had already moved to the relative safety of the stern. As they awaited rescue, they had to pray that what remained of the John P. Gaines wouldn't capsize. The ship's 4 lifeboats were launched, stationed nearby the stern in case it too should founder, and the crew struggled to make sure that her exposed bulkhead was turned to be protected from the relentless wind and waves. Volunteers threw together makeshift life rafts from strung together oil drums and hastily cut wood. Incredibly, the watertight bulkhead held, managing to keep them afloat until help arrived 33 hours later. Survivors were loaded into the lifeboats, cold, wet, and tired, only lightly clothed in the icy conditions thanks to how quickly they'd had to jump from their bunks during the night. The rescue efforts went on through the small hours. Grappling with the darkness and roiling waters, they attempted to set lines between the rescue ships and the wreck, but tragically, one lifeboat carrying 10 men was swept away after the heaving line broke, and it was never seen again. The 4th and final lifeboat was picked up the next morning, and the 70 total survivors of the John P. Gaines were delivered safely to Seattle, their ordeal finally over. Something was clearly up with these emergency wartime ships. In the end, some 1,500 examples of what were deemed significant fractures, that is, cracks in the steel, were discovered in the shell plating of their hulls, and 12 emergency wartime ships had broken apart without warning before the war was over. Hundreds and hundreds had been built, and they'd served well without being lost to structural failure, but enough had been lost that alarm bells were starting to ring, and then, 7 years after the war had finished, it happened again. It was the same nor'easter that had sunk John P. Gaines that took down 2 more World War II-era T2 tankers in February 1952. Built by the Sun Shipbuilding and Dry Dock Company and launched towards the end of 1945, the 10,000-ton SS Fort Mercer never actually saw service. Though the war was now over, many wartime T2 tankers were actually still in use. Some were being sold off and turned even into passenger ships, some were allocated and redistributed to US owners, and others were acquired by the US Navy. In the 1950s, both the SS Pendleton and the SS Fort Mercer were being used for fuel transport. Another product of the Kaiser shipyards, the Pendleton, like the Schenectady, had her start at Portland's Swan Island Yard. It was Tuesday, 12th of February 1952, that she set off from Baton Rouge, Louisiana, bound for Boston, carrying 122,000 barrels of kerosene and oil. That same morning, the SS Fort Mercer departed Norco, Louisiana, with full cargo and a crew of 44 headed for Maine. The first few days at sea were without incident, but by that weekend, as both ships neared Long Island, the wind started to pick up and the waves got choppier. A storm had begun to set in, one that would become one of the worst seen by the area in living memory. The crew of both vessels were now facing a perilous battle with the elements. Sea heights reportedly reached as much as 60 feet. Visibility was minimal with the snow driving on, and 70-mile-per-hour winds were so strong you had to lean into them just to keep your feet. The gale was only worsening as the hours passed, and then, a little before 6 a.m, Monday, the 18th of February, as the Pendleton continued to be buffeted by the waves off the coast of Cape Cod, an explosive-sounding cracking was heard. More quickly than anyone could possibly have the time to comprehend what was happening, the SS Pendleton ruptured in half between the number 7 and 8 cargo holds. There had been no warning signs. The bow section was rapidly carried away by the storm, along with the Pendleton's captain, John J. Fitzgerald, 7 other crew members, and the ship's radio room, leaving the remaining 33 crew members on the stern section with no way to send a distress call. They were completely alone. They acted with remarkable courage, keeping calm, and they worked quickly, shutting the watertight doors, and in doing so, enabling the stern section to actually just stay afloat. In lieu of a radio SOS, they managed to blow the ship's steam whistle by rigging it to a line and heaving on it. Now all they could do was wait for help. That is, if anyone would come at all. The Coast Guard was, however, already preoccupied. Around the same time as the Pendleton was grappling to stay afloat, the Fort Mercer was to become yet another T2 tanker to break in half. But in her case, though, the men were at least given a little more time to prepare. The first sign of what was to come arrived at 8:10, when, all too familiar by now, a whip-like crack was heard and the ship's load of oil started to spill into the surrounding ocean on the starboard side. Now, knowing full well the reputation and history of the earlier T2 tankers, Captain Frederick Paetzel turned the weakened vessel away from the waves in an effort to keep the fracture from propagating further, and then he radioed for help. At 10:30, the sound of ripping metal rang out again, and the tear near the number 5 cargo hold worsened, with still more fuel being lost to the waves. Another frantic SOS was sent out by noon. As the heavy seas continued to wreak havoc on the tanker, one last terrible cracking signaled what everyone aboard had been fearing those last few hours. The Fort Mercer's hull had been torn apart. The stern section, along with 34 of her crew, was drifting further and further away from the bow. Captain Paetzel and 8 of his men were precariously trapped in the bridge, not daring to move as the seas tossed the bow violently, and unable to do anything but watch as part of the deck was dragged below the murky waters, taking the ship's lifeboats with it. As if there wasn't already enough to concern themselves with, buffeted by the unrelenting winds, the bow, rendered completely at the mercy of the waves without any engine power, was now hurtling back towards the stern section, coming perilously close to colliding. Thankfully, the stern still had its engine, and the quick-thinking efforts of the engineers served to actually maneuver the stern out of the way of a potential collision course. 4 Coast Guard vessels, the East Wind, the Unimac, the Yakutat, and the McCulloch, had all been diverted to the Mercer's aid. At the Chatham Coast Guard station, 2 objects had been identified by radar operators, what they supposed at first were the 2 sections of the bisected SS Fort Mercer, but a Coast Guard PBY Catalina was sent to investigate and spotted that what they'd actually identified was the SS Pendleton, and it was suddenly apparent they were dealing with not 1, but 2 ships that were split in half and in need of help, and fast. The ensuing rescue has since been immortalised in literature and film, going down in history as one of the Coast Guard's most daring rescue attempts ever to take place. It was one little motor lifeboat, the CG 36500, that managed to heed the call. At just 36 feet long, the 90 horsepower TRS model lifeboat was massively dwarfed by the Pendleton's 504-foot long hull, and surely should be no match for waves as high as 6-story buildings. The crew of 4 was led by coxswain Bernard C. Webber. To say that the CG 36500's journey to reach the Pendleton's stern was treacherous would be an understatement. Immensely powerful waves were throwing the small boat around like a cat playing with its prey, at one point causing the lifeboat to fall onto her side and both the compass and the windshield to be shattered. In the words of Bernard Webber, the other men were knocked to the deck time after time. I thought several times I'd lost my whole crew. They looked like goners, but they managed to hold on. The stranded crew of the Pendleton had been waiting all day for rescue, unsure if anyone was even aware of their predicament at all. Fireman Frank Fateau would later state that the glorious sight of the bobbing light of the approaching lifeboat left them spellbound. Upon finally reaching the tanker's towering stern section, a process which itself had taken hours, the Coast Guard's troubles were far from over. All 8 crew who'd been stranded on the Pendleton's bow were lost. There was now a desperate rush to evacuate the remaining survivors from the stern while trying to prevent the lifeboat itself from being smashed into the Pendleton by the immense rolling waves. A light rope Jacob's ladder was lowered, and one by one the men began to make the hazardous climb down to rescue. Though the CG 36500 was only intended to carry a maximum of 12 passengers, due to the great bravery and determination of those involved, all but one of the 33 men was successfully piled into the tiny boat and brought to safety. The ship's cook, George "Tiny" Myers, who'd valiantly helped his fellow crewmen during the rescue, had been tragically lost to the sea. Meanwhile, back aboard the fractured remains of the Mercer, the 9 crewmen, including the ship's captain, had been crowded in the chart room without heat or light for hours now, and as midnight approached, the already listing bow had begun sinking lower into the sea. The men would have to move. Utilizing an improvised rope comprised of signal flags, they managed to successfully reach the forecastle ahead of them. Poor visibility and gale force conditions made their first attempts at rescue tragically unsuccessful, with 5 crewmen being lost in the process. The Coast Guard had no choice but to wait till dawn. As soon as there was enough daylight, the US CGC cutter Yakutat launched a monomoy surf boat to pick up the remaining survivors, including Captain Paetzel from the bow. Not without considerable difficulty though, using a combination of surf boats, shot lines, and a rubber life raft, all 4 men were eventually retrieved. Just 21 minutes after the last survivor had left the bow section, at around 10:51 AM on February 19th, it capsized completely. There was no loss of life from the Fort Mercer's stern section. In fact, 13 of the 34 men there opted not to be rescued straight away, choosing instead to stay on in the hope that they'd be able to possibly salvage the hulk. The stern was actually successfully towed a few days later, and eventually refitted with a new bow to become the SS San Jacinto. But the curse of the T2 tanker had not fully lifted. Thanks to an explosion in her cargo tanks, the San Jacinto would actually split in half again in 1964. So what had gone wrong? How was it that these innovative new shipbuilding techniques could result in vessels that would seem to do just fine on the water one day and then the next could suddenly break apart, even in seemingly benign conditions? The common denominator seemed to have been the new, prefabricated, all-welded ship designs. Similarities between these failures were starting to be recognised, kind of like patterns. Where significant structural ruptures had occurred, they tended to begin amidships, often when they'd been exposed to cold water temperatures, and the fractures would typically propagate out from a common origin, the square corners of the hatches. The sharp angles here created a stress concentration in the steel, exacerbated further by the frequent overloading during wartime conditions. But unlike when hull construction consisted of separate steel plates being riveted together, where each join could act as a crack arrestor, essentially preventing any fractures from spreading too far, the all-welded ships provided a continuous steel surface across which cracks could spread unimpeded. But early investigations were quick to place the blame on the inexperienced welders behind the construction of the Liberty ships and the T2 tankers. It was floated that poor quality welding had led to repeated incidents of ships breaking in two, and after all, it seemed the most obvious explanation. These weren't isolated incidents, and the evidence at the time did seem to point towards defective welding. The American Bureau of Shipping's investigations into the Schenectady's breaking up, for example, concluded that it must have been the result of locked-in stresses attributed to the apparently faulty welding. Therefore, if quality control of welding were to be improved, no further disasters should be seen. But as we know, after the Second World War, more problems did occur. Now later, as investigations reopened, it was supposed that notches in the steel rendered these tankers unable to withstand the bending of normal wave action without creating fractures, so it was proposed that the fitting of riveted steel straps across the hull could help remedy the problem. But both the Pendleton and the Fort Mercer had both been fitted with the mandated crack arrestors, so clearly significant structural failure was still going on. It wasn't until years after that those first ship's fractures had been spotted that research revealed the mystery of why these ships were splitting was far more complicated than first realized. Regardless of the quality of the welding work, these early ships could be more or less destined to fail for a much broader reason. This was in fact more of a question of metallurgy. Sure, a faulty weld certainly wouldn't help, but it was actually the chemistry of the steel used in the skeleton of the ship itself that was sealing their fates. The steel used in the construction of these ships did comply with the established specifications for standards at the time, But testing of steel like this was only required to be performed at room temperature, and only with a very small specimen size. The war industries were pushing production to a scale and speed never before seen, but this was still relatively early in the days of understanding the molecular structure of metal. Established testing methods were not yet capable of reflecting the extremes of operation. Because of this, early war mass-produced ships were effectively only being tested once they were already in use, which was of course far too late. They'd come to find that the ability to predict the performance of large steel structures would be vitally important, not just to help prevent further losses, but to help inform designers of ships into the future. Now, no testing variation was observed in riveted versus welded structures either, meaning that these tests weren't sufficient to flag the issues that would arise due to varied temperatures. But as it turned out, temperature played a huge part. Though it wasn't understood at the time, the suddenness of the SS Schenectady's breaking apart, though shocking, is a characteristic of what is called brittle failure. It was a woman named Constance Tipper of Cambridge University who first proposed the idea that it could be the properties of the ship's steel itself, not the welding work, that was causing Liberty ships and T2 tankers to become brittle. She linked the cold temperatures that the ships were being exposed to during service with a transition in steel behaviour from ductile, that is relatively soft and malleable, to brittle, that is likely to shatter like glass. With variations in the steel composition and the microstructure making fracture more likely in many incidences than in others, in the case of the SS Schenectady, it was found that despite the appearance of calm weather conditions at the time her hull broke, it was more so the cold temperatures of the North Atlantic that were the problem. Because of this, she developed a way of measuring brittleness using the so-called Tipper test, which is a method that's still used to this day. Now, using the Tipper test, it's possible to predict how different samples of steel would behave at different temperatures. It was indicated that when the steel contained too high a percentage of sulfur or phosphorus, it was much more likely to become brittle and prone to breakage. These kinds of impurities in steel could result from the hastened construction process, and of course, during the war, when materials were simultaneously in high demand and short supply, it was difficult to be picky. People have often wondered why Titanic, for example, broke apart when she sank, when other liners like Britannic and Lusitania were exposed to similar stresses on their hulls during sinkings without issue. But Titanic sank in water that was freezing, and her steel contained high concentrations of sulfur and phosphorus, thanks to the relatively primitive method of casting in acid-lined open hearth furnaces back then. Titanic wasn't badly built or designed. You couldn't blame her riveters for the breakup, but she was a product of her time, and the full microscopic characteristics of metal were not yet fully understood. As far as the Liberty and the T2 ships were concerned, the proposed solution of adding riveted crack arresters was very much like putting a band-aid on an open wound. Like with updated ship designs using rounded hatch corners wherever possible to reduce stress concentrations, these measures could, and did, help prevent fractures from escalating into total structural failure. But they didn't address the actual underlying problem, in that it was the metal itself that was failing. As a result of the research into these ships that split in half, it was now clearly apparent that using inferior grade steel was not an option, something that may have gone unnoticed if not for the phenomenon of the Liberty ship's rapid construction. In spite of their clearly less than ideal start, the truth was that Liberty ships and T2 tankers and the Victory ships were all instrumental to the war effort. Simply put, the war would likely not have been won that quickly without their contribution. Although the hasty construction times had their drawbacks in terms of structural integrity, the record-breaking construction was undoubtedly a significant achievement, and still to this day, being the most ships ever produced using a single design. It's unlikely that these construction times will ever be equaled again, nor hopefully will there ever be another need for such urgency that would require so many to be built so quickly. But probably most importantly, the learnings from these early failures of those vessels helped provide the very foundations of our understanding of modern fracture mechanics, informing and shaping future shipbuilding principles and safety guidelines, learnings that were applicable to other feats of engineering too, like bridges and aircraft. In spite of all their hardships, these ships ultimately provided a win, not just for the war effort, but for the advancement of scientific research, even decades later, to this day. On the topic of judging past construction techniques from the modern day, a conclusion found by a metallurgical study on steel samples taken from Titanic's wreck summed it up very well. The steel, they said, used in constructing the RMS Titanic was probably the best plain carbon ship plate available in the period of 1909 to 1911. But it would not be acceptable at the present time for any construction purposes, and particularly not for ship construction. If the Titanic had not collided with the iceberg, it could have had a career of more than 20 years, as the Olympic had. It was built of similar steel in the same shipyard and from the same design. The only difference was a big iceberg. The same is absolutely true of the emergency wartime ships. They were a crucial asset and a product of their time, and as our understanding of science and physics has improved, so too have our own standards. Part of our great understanding today has got to be attributed to the lessons learned from the ships that broke in half. Kaiser Wilhelm der Grosse. She was a ship that altered the course of maritime history forever. It introduced a new breed of ocean liner which reigned supreme for the better part of 15 years. Since the beginning of the 1800s, the biggest ships in the world had each, in turn, been British, with the occasional American interjection, but in 1897, the Kaiser Wilhelm changed all of this, and for the first time, the world's largest ship was German. Way back in 1889, during a visit to the Harland Wolff shipyard in Belfast, the Emperor of Germany, Kaiser Wilhelm II, had been particularly fascinated by the White Star Line's RMS Teutonic. After seeing firsthand the size, luxury and power afforded by the British liner, the Kaiser is said to have turned to an aide and said, "We must have some of these." And upon his return to Germany, the wheels were set in motion to build up Germany's presence in the North Atlantic passenger trade with a fleet of liners that would surpass those in service by Cunard and White Star. Kaiser Wilhelm der Grosse would be the first ship to be built with these aspirations in mind. In fact, the ship was so successful, she spawned 3 brilliant running mates, and even a close contender, the SS Deutschland. In 1907, Germany's dominance of the waves was at last shattered. Cunard Line introduced their own 4-funneled superliners, and again, Britain led the way. For the Germans, this of course would not do. Ocean liners had stopped just being private enterprises. They were now representatives of their own home nation's might and ability on the world stage. It's no wonder that at the same time Britain and Germany began to race to outdo one another with their passenger ships, their armies and navies were doing the same thing. With Cunard Line's Mauretania and Lusitania ruling the waves, and White Star Line working on a pair of superliners of their own, Germany had to respond, and they would have to do it in a big way. At the Vulkanwerke shipyard in Hamburg, Germany, kill plates were laid in summer 1910 for a monstrous liner that would dwarf the British ships and re-establish Germany as a world leader. Almost 3 years later to the day, in June 1913, the finished ship steamed on its maiden voyage out of Cuxhaven bound for New York. She was the largest ship in the world by a fair margin, and on her bow was fixed a massive bronze eagle clutching a scroll which read, "Mein Feld ist die Welt." My field is the world. The ship's name was Imperator. Imperator was a monstrous ship for her time, the first ocean liner to break the 900-foot length record and displacing some 53,000 tons. As always, the bigger the ship, the greater its amenities and standards of luxury, and in this regard, the Hamburg America line was keen to show the British how it was done. How this absolute marvel of a ship came to be is a fascinating story, and it starts with one brilliant man. Albert Barlin got his start in the shipping industry at age 17, when he took over his late father's maritime booking business. Under his guidance, the company began to thrive because his new and innovative ideas for increasing both efficiency and revenue had been a resounding success. The company would continue to grow under Barlin's leadership, and eventually he would find himself as the passenger manager for a shipping company called the Car Union Line. He led the company in a successful bid to undercut rivals on the migrant run to America. The effort lasted a decade, and one of the rival lines he had bested was Germany's Hamburg America line. In a twist, Hamburg America and Car Union announced their merger in 1886, spelling an end to the years-long rates war, but arguably, one of the most prized assets won by Hamburg America in this merger was their brand new passenger manager, Albert Barlin. His sharp business acumen and design sense made him invaluable to the company, and in 1899 he was promoted to general director of the line. But not content to merely keep the company on a stable course, Barlin had a grand vision for the future of ocean travel that would ultimately shape the industry into what we know it as today. Although he had got his start offering dirt-cheap transatlantic passage, Barlin's plans for the future of Germany's liner fleet were far more grandiose. He was a true visionary and risk-taker, and he desired not just to manage and maintain the status quo, but to push the shipping industry as a whole to evolve. Having spent years handling booking for steerage passengers, he was keenly aware of some of the drawbacks involved with sea travel. He envisioned a world where passage aboard a ship was no longer an ordeal to be endured, but an experience to look forward to in and of itself. Albert Barlin became the father of the modern cruise industry when, in 1891, the SS Augusta Victoria set sail for 6 weeks on the world's first pleasure cruise. The move in itself was a stroke of genius. Hamburg America Line had found that many of their passenger ships were becoming a money drain during the colder months. Bad weather and passenger aversion to a rough crossing had kept the line from being profitable during the winter, but by commissioning ships to run off-season Mediterranean pleasure cruises, the line's ships could remain in service even during the coldest months of the year. The idea was a hit, and travellers adored the sightseeing and shipboard accommodations. A voyage on a ship was no longer simply about the destination, the voyage itself was its own reward. As we now know, Barlin's daring idea to rethink ocean travel would go on to shape the future of tourism and birth a whole new industry in and of itself: cruising. Another secret to Barlin's success was the fact that he found favour with Kaiser Wilhelm II, who'd been quite vocal in his mission to see Germany lead the world in the luxury, speed and size offered by its passenger ships. The Kaiser's patriotic vision, mixed with Barlin's business acuity and design ingenuity, made for a powerful combination. Because of this, Barlin's vision for the Hamburg America fleet came with the Kaiser's blessing, and Germany would finally be able to give the British a run for their money. Barlin knew just how they would do it, by building the 3 biggest ships in the world. Work on Barlin's proposed grand trio of liners had commenced in 1910 at the Vulcanwerke shipyard, and this was quite a significant undertaking for the designers and shipbuilders alike. It would be the first time that a German shipping company and German shipbuilders would produce something of that scale. The last German liner to hold the size record had been the Kaiserin August Victoria in 1906, but this new generation of ocean liner would be twice as big. It was a daunting task, but Barlin knew that the timing was perfect. Cunard and White Star Line had spent the better part of the last decade trading blows by way of their ship design, and now Barlin was able to make use of the lessons that had been learned. Cunard Line's Lusitania and Mauretania had now been at sea for about 3 years, and they had experienced teething troubles Barlin would be able to avoid. He took notes from White Star's Olympic-class ships as well, and put them to good use in his new superliners. Imperator had been designed specifically to outdo the Cunard and White Star ships by elevating the passenger experience and transporting fare-paying customers in unbelievable luxury across not 3, but 4 classes. But beneath the sumptuous comfort and luxurious fittings was the steel skeleton and mechanical heart of an ocean-going giant. Imperator made use of Parsons turbines, immensely powerful engines. Cunard had used an arrangement of 4 turbines, each driving their own propeller on Lusitania and Mauretania, and Barlin recognised the arrangement worked well for ships of this scale. He opted to do the same thing with Imperator, and no fewer than 46 boilers would supply steam for 4 enormous turbines, which combined to generate 60,000 shaft horsepower. The brute force of these engines meant that Imperator could surge forward at about 23 knots, only 2 knots slower than the Cunard ships, despite the fact that she was larger by 20,000 tons. In itself, a highly impressive engineering accomplishment. Imperator's interior design was no pale imitation of her British counterparts either. No, she would be the final word in luxury at sea. Barlin had banked on the fact that an improved standard of luxury would win out over sheer speed. He'd seen this work for the White Star Line when Olympic was introduced to much fanfare, and now it was up to him to best the standard, and to do it, he'd need to rely on a genius. Fortunately, he knew just the man. Charles Meues was widely renowned for his work designing the famous and exquisite Ritz and Carlton hotels. He would be the man to design Imperator's interiors, but his involvement presented another interesting twist for the ship's conception. Meues' business partner was a British architect named Arthur Joseph Davis, and he had been contracted to design the interiors on Imperator's newest British rival, the Aquitania. The two business partners would now be working for competing companies at the same time. Cunard Line and Hamburg America came to an agreement. Meues would work in Germany designing Imperator's interiors, and Davis would stay in England working on Aquitania, and neither business partner was allowed to disclose the details of their work to each other. Like Barlin, Meues was a man of exacting standards, known for his almost obsessive eye for detail and painstaking insistence on precision. His work on the Ritz hotels, the Royal Automobile Club, and dozens of private residences was deeply revered. He had actually worked with Hamburg America Line and Barlin before, first on the SS America and then the Kaiserin Augusta Victoria. His use of clean, white spaces with tasteful gold detailing had become something of his signature, and wherever Meues' designs went, the affluent would inevitably follow. But in this project, he had his work cut out for him. Imperator boasted vast, open public spaces and staterooms, the likes of which had never been seen on an ocean liner before. With much more space to fill to the brim with splendour, Meues got to work designing some of the grandest rooms of his career. But there was a reason that Meues was working with so much space, because it all came down to the way the Imperator had been laid out. Crucially, the ship had broken with tradition. For 15 years, the world's largest liners had sported 4 funnels. The number and size of the ship's funnels had become associated with her size and power itself. But as ever, Barlin, never one to follow tradition, grabbed the opportunity to innovate. Imperator was bigger than any ship yet built, but she would only have 3 funnels. It meant that the ship's interiors wouldn't be split up by towering uptakes which reached from deep down into the boiler rooms right up to the funnels. In older ships, the public rooms had to be designed around the uptake's casings, but with only 3 funnels, it meant that the 53,000-ton Imperator's rooms could be bigger because the uptakes were fewer and spaced wider apart. Between this bit of brilliant engineering and Meues' exacting eye for detail, what resulted was nothing short of majestic. Imperator's first-class spaces were some of the most beautifully decorated and spacious ever put to sea. To say the ship set a new standard for luxury would be an understatement. The first-class spaces were palatial. Almost amidships was the towering Ritz-Carlton restaurant, an upscale dining experience to rival any found on land. Charles Meues, of course, had a long-standing history, having worked with Caesar Ritz to design his hotels, so he was able to offer full Ritz-branded dining accommodations on board the ships that he designed. For an additional fee, first-class passengers could enjoy all the pomp and luxury they'd come to expect from any Ritz establishment while steaming at some 23 knots across the vast Atlantic Ocean. The restaurant was fully staffed and managed by Ritz employees and functioned as an entirely separate entity from the rest of the victualling services on board. This ensured that guests were treated to the same unmatched quality as any other Ritz restaurant they would have found in Paris, New York, or London. On Imperator, the Ritz restaurant appeared to be less of a dining establishment and something more like a Baroque theatre, with the restaurant elevated on a stage-like platform and divided from the equally sumptuous Winter Garden lounge via a carpeted staircase. This arrangement of an elevated dining space with onlookers peeking in from the lounge below provided diners with a sense of privilege and nobility. To dine at the finest restaurant, on the finest vessel at sea, on what felt to be a grand stage. But of course, Meues provided the Imperator with much more than a fine dining option. Also notable on board the ship was the inclusion of the largest gymnasium ever seen at sea to that point in the extremely popular Pompeian-style pool, which towered 2 decks in height and sported massive ornate columns with gold detailing and marble benches. Mewes must have been quite proud of this design because it's almost an exact replica of the same that he'd implemented for the Royal Automobile Club. Now, this in itself was a departure from the Spartan, bare steel and boring tiling found in the pool areas on board ships like the Olympic class. The pool area connected to a Turkish and electric bath, massage rooms, a hair salon, and a sauna. Beyond this, Imperator was known for offering staterooms that were far more spacious than those offered by Cunard or White Star's ships. Gone were the days of cramped berths and tiny portholes. Rooms were now bright, open, and more comfortable than ever before. It was the design of the first-class lounge that seemed to suggest a rather novel concept for the time, a room built specifically with ample room for entertainment. Mewes seemingly designed the lounge with a new philosophy. While there were still spaces which offered men and women seclusion on board the ship, the brightly lit, wide open space of the first-class lounge seemed to invite couples and families to socialise together. At 72 feet, that's 22 metres long, and with its massive dance floor and little in the way of partitions or columns, men and women alike were encouraged to use all the space that they could, and this included for musical and theatrical performances on a large stage at one end of the hall, which was the first of its kind seen on a liner. The interior design on Imperator was a testament to Germany's determination to excel over their British counterparts in as many aspects as possible. Almost every first-class stateroom was an outside cabin, with its own porthole, and 150 had their own ensuite bathrooms. 2 imperial suites, reserved for the richest of the rich, comprised no fewer than 12 rooms each, including a breakfast room, a sitting room, private promenade, and even a servant's quarters. Imperator even had her own florist shop. Of course, first class boasted all the finest accommodation, but as ever the standard of luxury was maintained across the rest of the ship. For the first time on an ocean liner, second-class passengers got their own gym. There was a music room, smoking rooms, lounges. Second class on Imperator was as good as first class on almost every other ocean liner then in service. But just as Imperator was being completed, Cunard Line dealt Hamburg America a blow. It came to light that the Aquitania was being designed to be longer on completion than the Imperator by a single foot length. Now, not content to take home second place once again, but with nowhere near enough time to adjust the ship's design for additional length, a quick fix was decided on by the company that would both solve the issues of Imperator's inadequate length and also serve as a symbol of Germany's seafaring might. Designed by Professor Bruno Kruse of Berlin, a massive bronze eagle displaying the words "My field is the world" was affixed to the ship's prow, its wings outstretched, and a globe held in its talons. In a funny twist, it would ultimately prove unnecessary. Aquitania was never designed to be longer than the Imperator. It was just a simple misunderstanding. Finally, by May 1913, Hamburg America Line was proud to introduce their flagship. It had been an achievement unparalleled in the history of German engineering up to that point. But as ever with breaking new ground, there came unintended consequences. Making her way down the Elbe River towards the North Sea for the first time, she quickly ran aground, a result of her staggering size contending with the narrow channel. Worse still, a fire on board, started by a workman accidentally, claimed the lives of 5 crewmen, and the damage would delay Imperator's maiden voyage. But critically, it also became clear during her short initial sea trials that the imposing hulk of the ship made her very top-heavy. The crew noticed the ship's tendency to roll easily, where she would seem to hang, hesitant to return to an even keel. These design flaws would need to be addressed, but there was no time to go back to the drawing board and add any permanent fix for the instability issues. Imperator would need to be delivered to Hamburg America Line, top-heavy though she was, in anticipation of her highly publicised maiden voyage. As completed, Imperator was 8 feet longer than Aquitania, 7,000 tons larger, and capable of carrying a staggering 1,200 more passengers. The first few voyages on board Imperator were lauded by the public, who praised her lavish interiors, hotel-like atmosphere, comfortable staterooms, and beautifully designed public spaces. Slowly though, word began to spread around that life on board this floating palace was not what it appeared to be. Over the first few weeks of her sailing, passengers began to get increasingly frustrated with the ship's tendency to roll to one side at the slightest breeze. The ship's designers had anticipated some degree of instability in the ship, and they had installed an innovative system of anti-rolling water tanks within the hull that could be used to counterbalance the ship. The issue was, the system required the crew to anticipate the rolling ahead of time. This was nearly impossible to do so. There was no telling when the wind would blow just the right way to knock the hull off centre, so the anti-rolling system did precious little to remedy the problem. Many passengers insisted that the vessel never sailed on an even keel throughout her first season. It quickly became clear that the ship's top-heavy construction, coupled with damage from fires having occurred on board during her first few months, could not be easily repaired between voyages. To address these issues, Imperator needed a full refit only one season into her career. This would see her towering funnels shortened, heavy furniture be replaced with lighter wicker alternatives, and bulky wood panelling be replaced with lightweight fireproof sheeting. Now, the changes to the interior design would probably have been an affront to Charles Mouves, a man very particular about details and faithful to his Ritz-style design choices. But fire prevention systems were installed too, a response to the ship's desire to seemingly want to catch a blaze at random. All told, this refit would wind up costing the shipyard hundreds of thousands of marks on top of the already staggering cost of the construction, and the stability problems largely persisted for the remainder of her career. It earned the ship the embarrassing nickname L'Imperator. It's important to note that Imperator was essentially a prototype. Hamburg America Line wanted to take the ideals of luxury and might and blow them up on a scale never before seen, but unfortunately this came at the expense of the ship's stability. Despite these teething troubles, the ship drew an impressive number of passengers during her early days at sea. She was a triumph for her builders and designers, and a momentous feat by the German mercantile marine, who had proven that they could compete with the British shipping juggernauts. But even then, word was beginning to spread of the impending introduction of Imperator's planned sister ship. With the maiden voyage of Imperator, the Hamburg America Line was officially a force to be reckoned with. Now, they had to repeat the success. Barlin had always known that one ship would not be enough. He would need to take the lessons learned on Imperator and improve on the ship's design. The second in the trio would do just this, and in May 1914, the enormous hull of the new ship steamed into New York for the first time. Her bow featured gorgeous, ornate scrollwork that elegantly pointed towards her nameplate. It was a name that represented Germany itself. The new ship had been named Vaterland. At 950 feet in length, 53,500 gross registered tons, and capable of thundering through the water at a speed of 26 knots, she quickly outpaced Imperator as the largest and grandest liner afloat. She benefited from the lessons learned during the design of that ship as well. It was noted by many that Vaterland was far more stable than her constantly rolling running mate. But something important had happened in between the time that Albert Barlin's giants had been ordered and then finally introduced. Titanic had sunk. This shocked the world's maritime industries into action because the public had suddenly lost confidence in the safety of the ocean liner as a whole. But Barlin's ships benefited from the Titanic disaster. Lessons had been learned and implemented as the ships were being built. There were some easy fixes. Imperator and Vaterland were two of the earliest ships to set to sea with lifeboats for all as new, but that wasn't enough. The interiors of the ships featured double bottoms, inner skins, and compartmentalization that far exceeded what had been used on Titanic. Wanting to assure an anxious public that these new and innovative German liners were the height of safety and security, Vaterland was put through a daunting test. Before her sea trials, the ship was brought out to deep ocean, where 1/3 of her watertight compartments were allowed to flood. Watching nervously as the vessel took on water, the shipbuilders and crew held their breath as the integrity of their work was tested in real time before their eyes. The trial was a success. Vaterland remained afloat, but while the test did prove the apparent safety of the ship, many builders agreed that it was one of the most extreme trials that a ship had been put through in history. Pumping the massive volume of seawater out was another undertaking altogether. Regardless, the experiment was an effective display of the Vaterland's safety and strength. Had she been the ship to face Titanic's iceberg on that cold April night back in 1912, Vaterland would have stayed afloat. Not only that, but the ship carried 83 lifeboats. Titanic had only carried 20. But it wasn't just safety lessons that had been learned either. Barlin and Mouves wanted to take the work they'd done with Imperator and push it to the extreme. The ship had benefited from having only 3 funnels. It meant that her interior rooms were some of the largest at sea. Barlin wanted to implement an ingenious engineering trick that would mean Vaterland's interiors would be even bigger. On most ships of the day, the funnel uptakes carried smoke from the ship's boilers through the middle of the ship, but Vaterland's uptakes were split. They'd rise from the boilers at the bottom of the ship, run outwards towards the hull, then run up and meet again at the funnel's base at the very top. This created a massive interior space that was uninterrupted by machinery or uptake casings. Vaterland would feature all the glorious spaces Imperator had, but now passengers could walk through them, one to the next, unimpeded, in a giant kind of sprawling vista. If the goal was to make travellers forget they were on a ship at all, then Hamburg America was nailing the brief. These ships had evolved far beyond what you would ever expect to find on a vessel even a decade or so prior, with size, scale, luxury and safety all dwarfing shipboard offerings that had, once upon a time, been considered a triumph. Charles Moues' business partner offered his insight to the Royal Institute of British Architects. He said, "If we could get ships inside to look like ships and get people to enjoy the sea, it would be a very good thing, but all we can do, as things are, is to give them giant floating hotels." No other pair of running mates at the time embodied this philosophy better than the Imperator and the Vaterland. Vaterland's 4,050 passengers would be fed by 8 enormous kitchens. She shipped 45,000 pounds of fresh meat alone. That's over 20,000 kilograms per voyage. In her pantries and bars were stored 17,500 bottles of wine and champagne, and no less than 28,000 litres of German beer. These German responses to British supremacy at sea seemed to be a resounding success. Once the third and final sister ship was completed and put into service, Cunard and Hamburg America Line would be the only 2 shipping companies on the transatlantic run to be operating a 3 superliner fleet. This likely would have been a sore spot for White Star. The Olympic class, of course, had been planned as a trio, but the loss of Titanic and the delay on Britannic because of that meant that they would never see their 3 grand sister ships running side by side. For a brief time, this war for transatlantic supremacy and the passenger trade was reaching a fever pitch. The world waited anxiously to see how White Star and Cunard would respond to the Grand Barlin trio once the final ship took to the sea. Unfortunately though, a different kind of war was on the horizon. This one would not be fought with specifications, design flourishes, or top-tier service. This was the dawn of the First World War, and the era of Edwardian luxury superliners was about to come to a crashing halt. World War I broke out just a year into Imperator's career, and barely a month after Vaterland's maiden voyage. The world's attitude towards shipping had shifted overnight. Grand and gilded liners designed as floating hotels, whisking travellers away across the ocean, were now seen as accessories of wartime. Once immaculate liveries were painted over in drab camouflage colours, guns were affixed on decks, ammunition filled cargo holds. Lookouts were now trained to not only watch for icebergs or rocks, but the approach of enemy vessels, torpedoes, and submarines. Albert Barlin, with his incredible foresight, had seen the writing on the wall. He had anticipated the possibility of naval hostilities, destroying his many years of hard work. In the years leading up to the war, Barlin had tried to act as a mediator between the Germans and the British, having sensed the diplomacy between the two sides beginning to break down. Barlin hoped that Britain and Germany could reach an agreement where the two nations would continue to compete with one another only in the transatlantic passenger trade, rather than devolving into a full-out naval arms race. Try as he might though, in July of 1914, Britain and Germany found themselves on opposite ends of the largest contest of military might the world had ever seen. The Oceanliner was going to war, and things would never be the same. While 80 of Hamburg America's 175 ships were docked at German ports when the war had started, 12 liners were docked in neutral ports, and they were almost immediately confiscated. To Albert Barland's absolute dismay, one of those ships was the Vaterland. While Imperator was back in Germany, home and safe, Vaterland had been docked at New York at the start of the war, with the captain unwilling to take his ship on a mad dash across a dangerous Atlantic Ocean for home port. Vaterland was summarily confiscated by the United States and mothballed at Hoboken, New Jersey. While hundreds of thousands fought and died on the European continent, America began to realize that it might need to get its own troops across the Atlantic Ocean. A giant German ocean liner would be the perfect transport. Vaterland was converted into a troop ship to serve in the US war effort, making her known as one of the world's largest prisoners of war. She was even renamed. The Americans called her USS Leviathan. Having sat idle for the better part of 3 years, in December 1917, after the US had finally entered the war, Leviathan set off on her first voyage, carrying over 7,000 American troops. In subsequent voyages, this number would be increased to a staggering 14,000 troops. But this was only possible because the beautiful interiors of the ship had been ripped out. The darling of the German fleet was largely stripped of her finery. Her grand dining room had been converted into a mess hall. The famous ballroom and social halls had been converted into a hospital. The marble halls of the Romanesque swimming pool now served as a baggage hold. Being the largest ship at sea, and one of the fastest, worked to her advantage in wartime. She was free to travel without the need of an escort or convoy, because it was believed that she could simply outrun any U-boat that might try to target her. At the same time, Albert Barland was dealing with struggles of his own. His attempts to mediate between Germany and Britain had failed. He had to watch on helplessly as the war had spelled the end to his record-breaking trio of ships. The third sister ship had been well underway at the start of the war, but now she sat languishing, stripped of copper and brass for the war effort. It was a pathetic and heartbreaking sight. Barland had grand plans. He was a dreamer, fiercely proud of his creations, but world events had turned his dreams into a waking nightmare. His relationship with the Kaiser, with whom he'd always enjoyed a great deal of camaraderie, was beginning to sour, and word was beginning to spread that Barland was not a supporter of the war effort, and it was no longer beneficial for the Kaiser to keep Barland close. In 1918, the two were no longer on speaking terms. With his world falling apart and his greatest ship yet, Vaterland, stripped of her splendour and in American hands, it all proved too much. Albert Barland died of an overdose in 1918, 2 days before the war ended. Shockingly, his death received almost no coverage from the German press because it had been overshadowed by the magnitude of world events. By the end of the war, Hamburg America Line, like the rest of Germany, was in a shocking state. It would take many years before the company could stand on its own 2 feet again, having been completely obliterated by the war and the loss of their genius leader. It was a tragic end for what had been a glorious undertaking. But even though Barland's dreams would go unfulfilled, his gift to the world was a trio of spectacular ships that had pushed the limit and driven the development of the ocean liner even further. And even though this was the close of one chapter of these ships' stories, a curious twist would see the Barland ships receive a second chance at life. The war had not been kind to the world's merchant navies. Hundreds had been sunk and some household names had been lost. Lusitania was spectacularly sunk in 1915. She'd been a floating celebrity for nearly a decade. Her loss was a massive blow for the Cunard Line, who were relying on her to form part of their grand trio of transatlantic liners. White Star Line copped a devastating blow too. Britannic, intended to be the running mate to Olympic, was lost after she hit a mine in 1916. The massive ships would need to be replaced, and there, lying at anchor, were two of Baaland's giants. Imperator had sat mothballed at Hamburg for 4 years, and the third ship was unfinished, still with her funnels unattached. As always in wartime, to the victor goes the spoils. America would keep Vaterland, now Leviathan, as a war reparation, while Britain would take ownership of the other two sisters. For the German merchant marine, it was a devastating blow, but nothing could be done. As 1918 rolled into 1919, and then 1920, the world slowly began to recover from the horror of the war, and plans were drawn up for the Baaland ships. His trio would live on, but they would never serve together, and instead, they would be pitched against one another in foreign hands, as rivals. (1921), the second year of a new decade. The bleakness of the war had slowly begun to give way to a new era. It was the birth of the Jazz Age. In America, the Volstead Act had been passed and prohibition had begun. At sea, the great shipping companies had been hard at work. The end of the war presented new opportunities because suddenly hundreds of thousands of European people sought to move to escape the war's carnage and seek new lives. As ever, the great British shipping companies were at the forefront. Aquitania and Mauretania were put to work, earning a fortune and transporting thousands. But sailing alongside them was a new addition. With enormous red funnels, you might have thought, looking on, that this might have been a sister ship to Aquitania, if not for one obvious difference. The ship didn't have 4 funnels, she only had 3. The massive liner had been dreamt up a decade ago by a German genius, but now she was one of the biggest ships in the British merchant marine. Her name had once been Imperator, but now, flying the blue ensign and the Cunard House flag, her gilt letters spelt out a different name. The name of an English queen. She was called Berengaria. Since 1914, Imperator had remained tied up at Hamburg, occasionally being stripped of some expensive bronze fixtures while being largely left to rust. After the war, she was briefly handed over to the US under the terms of the Treaty of Versailles and used as a transport to bring American troops home alongside her sister ship, Leviathan. But just a few short months later, Imperator was given back to the British shipping controller. Because the Cunard Line had suffered at the hands of Germany's U-boat fleet, they needed a replacement for Lusitania, and Imperator, they got it. The ship was handed over, and she flew the British flag. And after a series of lackluster voyages as the RMS Imperator, it became clear that the ship was in dire need of an overhaul. In 1921, she went in for 6 long months and re-emerged, refreshed, the largest ship in Cunard's fleet. But sadly, the Ritz-Carlton restaurant, Mouesse's pride and joy, didn't make it. The space was gutted and turned instead to a dance floor, truly a sign of the times as the Jazz Age took over. But probably the biggest change came to the ship's power plant. As built, Imperator had carried thousands of tons of coal, which needed to be shoveled by hand by over 100 stokers. But a new technology would change all of this: fuel oil. Now ship's boilers could burn liquid fuel instead. It didn't need to be shoveled in, it could be pumped from tanks. And refueling had been a days-long process, but now it could be done in a matter of hours. The ship's boilers were overhauled and the bunkers could ship 6,500 tons of liquid fuel. Eventually, virtually all major coal-fired ocean liners like Olympic and Aquitania would get the same treatment. The age of coal at sea was over, and a new technological age had begun. Meanwhile, many of the other changes Cunard made had been with weight saving in mind. Despite efforts from her original builders, Berengaria was still top-heavy and quite a roller. Tons of cement and pig iron were laid in the ship's bottom to try to keep her on an even keel, and most of the furniture was replaced with more modern, lightweight pieces. The end result was a refreshed liner that carried most of Imperator's pre-war splendour. She became a popular choice for travellers who spent many nights of the 1920s dancing away to the ship's onboard orchestras. She was Cunard Line's flagship and sailed wearing the company's colours for 18 years. But of course, she was not British built. A strange fact which didn't matter much to the travelling public. Berengaria was still a very happy ship. You can see it in the thousands of photos of happy passengers dressed in their best. At last, Cunard Line was operating a regular 3-liner service across the Atlantic with Mauritania, Aquitania, and Berengaria. A strange lineup, but a proud one nonetheless. For Cunard Line, the 1920s would be happy years, thanks in large part to Berengaria, but the ship's younger sister, Vaterland, wouldn't be so lucky. After the First World War, Vaterland, renamed Leviathan, had worked hard to transport thousands of troops across the Atlantic to bring them home to America. The ship, like her sister, developed a bit of a reputation for rolling, and on long crossings, American troops would tell the same joke. "There's a torpedo," one would shout, and someone would reply, "Thank God." They just wanted to be put out of their misery as they swayed back and forth. Leviathan did her job just fine and earned the nickname the Big Train, but by war's end, she was clearly clapped out. The ship had been basically brand new before the war and had only completed 4 Atlantic crossings under the German flag, but by 1920 she was clearly very tired. Not only that, but tastes had already begun to change, and by the 1920s, the ship, which was naturally very German, was unlikely to appeal to an American traveller. She'd need to be extensively overhauled, and a simple refresh just wouldn't cut it. Structural changes would need to be made, but to do this, the Americans needed plans. And here there was a problem, because Blohm and Voss, the original German builders, were holding the ship's plans ransom. They offered to sell them for $15 million in today's money, which was, at the time, an outrageous sum, and the new US owners simply balked at it. They'd have to get creative. They'd have to make their own plans, and to do it, they'd need to recruit a small army of men to measure every inch of the ship inside and out to draw a set of plans up from scratch. And to oversee the monumental effort, the United States Lines, the new owners, needed a keen eye and a cool head. They awarded the contract to a young, up-and-coming naval architect and his brother. The man's name was William Francis Gibbs, a quiet and determined young man who would one day go on to design one of history's greatest ships. But for now, he and his brother Frederick busied themselves with mapping Leviathan from the inside out and planning to rebuild the Teutonic liner as an American one. The task was staggering. Gibbs himself said, "There was nothing to go by but the ship herself. We knew nothing whatever about her. We did not even know where her centre of gravity was." It took a full year for Gibbs and his team to draft a monumental set of specifications, 1,024 pages long. 13 pages were dedicated to clock-face design alone. In 1923, half a decade since the war had ended, a ship emerged sporting the red, white, and blue funnels of the United States Lines. She had kept her wartime name, but now she had been finally restored to passenger-carrying glory. She was the SS Leviathan. William Francis Gibbs' attention to detail and genius rivaled that of Leviathan's creator, Albert Barlin. It had been a monumental task, but the Gibbs brothers, in conjunction with the Newport News Shipbuilding Company, had transformed the old Vaterland into what was essentially a different ship. The reconditioning took more than a year. Like her older sister, the liner had been converted to burn oil instead of coal, and all her interior wiring and plumbing had been ripped out and fully refurbished. Steam heating, new galley and cooking equipment, the old stuff had been taken out and new machinery put in. Even the engines needed a total overhaul. When she had been converted into a troop ship, 1,200 staterooms had been ripped out, bathtubs had been removed by sledgehammer, cushions and furnishings had been simply tossed overboard, and leaded glass windows were smashed out. Art was looted and sold on the black market. Barlin's grandest liner had been reduced to a husk of its former self, and Gibbs had set about restoring her completely. The Ritz restaurant was stripped right back to bare steel and then reinstalled, but where a portrait of Prince Ludwig of Bavaria had hung in a public space, now a portrait of US President Warren G. Harding sat in its place. The spate of luxurious public rooms was all there, the lavish winter garden, the spacious ballroom, Leviathan entered service in summer 1923 to much fanfare. Gibbs and his team, as well as thousands of hands from the Newport News shipyard, had done it. They had taken the forlorn, poorly Vaterland and transformed her into a floating palace that Barlin, if he was still alive, might have been proud of, despite the fact that she was in US hands. American dock workers were unused to such a massive vessel. Upon her delivery at Boston Naval Dockyard, the men were taken aback by the massive size, with one tug captain shouting, "Where do you tie a line to this goddamn hotel?" Leviathan set out on what could be considered a third maiden voyage. She was by now almost a decade old, but had only served as a passenger liner for a few months. United States Lines had a flagship, and for the first time in decades, one of the largest passenger ships on the transatlantic run was American flagged. But what had started out as a glorious return to form quickly lost steam. Leviathan soon began to operate at a loss, and one key reason was drink. Being an American flagged ship during Prohibition, alcohol couldn't be served on board. The ship was still the pride of the American merchant fleet, and an ocean-going celebrity in her own right, but she would just never reach the same levels of success and popularity as her sister ships. Cunard and then United States Lines had both taken a Barlin sister ship and repurposed them in different ways, but Barlin's ships had been intended to be a trio. Way back in 1912, when he'd been planning the third and final sister, he knew she would need to improve again on the formula that he'd set into place. Imperator had been praised for her lavish interiors. Vaterland had taken these interiors and scaled them up. The third sister would be the culmination of Barlin's dream. She would be named Bismarck, after the great German statesman, and she would have embodied all of Germany's pride and engineering might. But tragically, for Barlin and for the nation as a whole, the First World War stopped her construction dead in its tracks. She had thundered down the slipway in 1914, but then sat for years, languishing as a hulk, incomplete, and even lacking her funnels. 5 years after work had been started, the rusted skeleton of Bismarck was confiscated by the British as a war reparation, but then acquired by none other than the White Star Line. That vaunted company had been dealt a devastating blow when they lost their own superliner Britannic to a German mine in 1916. And Bismarck, almost 10,000 tons larger, would be her replacement. White Star Line had worked for decades, having their ships built by the Harland & Wolff shipyard of Belfast, but that yard was almost 2,000 miles away by sea from where Bismarck had been laid up at Hamburg. But the German shipyard promised to finish the ship to the exacting standard as if she were going into German ownership, mostly to the original plans and specifications and almost exactly as Barlin had imagined her. But it would not be smooth sailing. In 1920, as work was going on, a fire mysteriously broke out that many thought was set by German workers. The fact this proud nation was now forced to turn over its greatest creation yet was a massive blow. By 1922, the work was finally complete. Bismarck had been finished by Blohm & Voss, but in a final act of defiance, they had finished the ship in Hamburg America Line's German colour scheme. Once the immense ship was ready for official handover between Germany and Britain, it was found that there had been a few key details overlooked. British officials and the ship's new commander, the White Star Line veteran Bertram Hayes, had travelled to Germany to take possession, but then found that their quarters were still unfinished, but the quarters of the German crew were completed and spotless. Hayes' own cabin was being used to store wash basins. But despite the obvious rancour, Bismarck was handed over to the White Star Line and she steamed away for her sea trials. Hundreds of locals watched in silence as their creation sailed off. Even though she flew the German flag for her trials, a report stated that the city's inhabitants watched the scene with aching hearts. Bismarck would be the largest ocean liner Germany would ever build, and the largest ship in the world for 13 years. For the White Star Line, things were beginning to look up at last. A dream that had started years ago in 1907 was finally being realised. The company had wanted to introduce a trio of superliners for the prestigious New York service, but Titanic had been lost, and then so had Britannic. In the summer of 1922, they were at last able to introduce a suitable running mate to the sole surviving member of the class, Olympic. That ship had served valiantly for years, and now a decade after her debut, she had a strange kind of sister that wasn't British, but German-built. With her 3 towering smokestacks now sporting the White Star buff, the new liner looked resplendent. Gone was the name Bismarck. The new ship steamed for New York, for the first time proudly wearing the name Majestic. White Star Line's acquired liner was a triumph for the company. She was 10,000 tons larger than Olympic and vastly more spacious and luxurious. Olympic's interiors were like a stately British country manor, but to travel on Majestic was like staying at the Savoy or the Ritz. White Star was so impressed with Moues's interior designs that they incorporated his furnishings into the ship even though he had essentially designed them nearly a decade prior. There were all the same famous spaces as passengers had come to expect on Barland's other ships. The towering lounge, free of columns and annoying pillars thanks to the genius of the ship's interior engineering. White Star had taken the opportunity to convert their ship to burn oil as well. Now all 3 of the Barland ships had been modernised and burned the much more economical fuel. At full steam, Majestic, despite her immense bulk, was capable of hitting up to 26 or 27 knots, a testament to the sheer power of her engines and the efficiency of her shape. When she arrived in New York for the first time, she caused a stir. The old Mauretania dipped her flags in salute as she passed outbound, her decks crammed with passengers who were keen to get a glimpse of this new generation of ocean liner. Moored at the pier, with over 40 feet of her stern overhanging into the Hudson River, more than 10,000 people came out to see her. It was a fortunate sign. Majestic would prove to be a smashing success for the White Star Line. They would never quite introduce a 3rd ship that could live up to the standards set by Olympic and Majestic, but the liners worked together for the rest of the 1920s, and the White Star Line flag flew high and proud across the Atlantic. The 1920s were a dizzying, heady era. On the one hand, it was a decade of merriment, partying, furious jazz, incredible wealth and decadence. But on the other hand, it was a decade of immense turmoil, the rise of dictators, an impending stock market crash. But through it all, Barland's trio of ships operated not as running mates, but rivals. The maritime genius who had dreamt the giants up wasn't around to see them in their glory years. It's hard to just encapsulate in a video, even one as long as this, just what those years must have been like. A ship is a strange thing. It's like it has a beating heart and a soul. It's shaped out of steel and iron, but then it takes on a persona thanks partly to its insides and how it makes its passengers feel, but then also thanks to the thousands of workers, crew and staff who make it a home. Passengers would travel on certain liners because they knew and loved members of the crew. Some stewards who served on board Olympic, for example, had been there since its maiden voyage in 1911 to its scrapping in the 1930s. Barland's 3 ships took on personas of their own too, and over the many years they were in service, there were countless human stories that played out. Love affairs, scandals, dances, fine dinners. Aboard there were celebrities, royalty, athletes, statesmen and migrants alike. The liners saw the beauty of the ocean in all of its moods, from the stillness of a fine sunset to the terrifying roar of an Atlantic winter storm. They battled waves that towered over their decks and dwarfed piers and tugboats on either side of the Atlantic. They were legends of their time, the very pinnacle of Edwardian engineering. But by the late 1920s, times had well and truly changed. Barland's trio had been in service for 15 years, but they had not been easy years. The ships, all 3 of them, were beginning to show their age. During her reconditioning, Leviathan had had her wiring ripped out and replaced, but the other 2 sisters did not. As a result, they suffered fires and failures over the years, and then cracks in the shell plating began to show. Leviathan was hit by a wave so hard that it cracked some of her frames out of true and opened up a 100-foot-tall gash in the hull. The size and majesty of these ships had lulled British shipbuilding into a strange kind of stupor. The intense race to build increasingly larger passenger ships that had taken place for decades before the war had eased off. Britain's great shipbuilders began to build more modest intermediate cabin liners. White Star and Cunard already had their superliners after all, and their old continental European rivals, like Germany, had been knocked out of the battle. Or at least they had, for a while. German shipbuilding and industry had been devastated by the end of the war, but it had not been halted forever. As the years passed and Germany found her feet again, one of the nation's premier lines began to make big plans. The winds of change were blowing. The 1920s were nearing their end, and the three most celebrated ships at sea were from a different age that no longer existed. Now, Art Deco reigned supreme. Tastes were always changing, and the British and American lines had been content to operate the Barland ships without fear of contest. But now, the company North German Lloyd set out to change this. The Oceanliner had risen from the 19th century as an alternative to the sailing ship. It had rocketed forward in leaps and bounds, but then, for 15 years, it remained largely unchanged in its basic form. What North German Lloyd was about to build would change the game forever. The Oceanliner was about to take a radical step forward into the future with a pair of sister ships that would shock the British into action and result in a series of vessels that would enter the history books. It would all culminate in the construction of true maritime legends and some of the most intense ocean-going rivalries of all time. Barland's trio of ships had been a huge step forward for their time, but the Edwardian superliner was dying out. A new age was about to begin. It's 1958 and a major motion picture is about to premiere. The media is whipped into a frenzy because this is not just any film. A Night to Remember is based on a legendary book of the same name, and it details in graphic reality the sinking of Titanic, which had occurred just 46 years earlier. On the red carpet that night is the usual assortment of producers, directors, writers, and actors, including massive names of the day like Kenneth More, but mixed in with that crowd were three elderly gentlemen who might have gone unnoticed by the press and the crowd, but their story and their importance couldn't be understated because they'd actually been there that night when Titanic had sunk. Their names were Joseph Boxall, 4th officer, Herbert Pittman, 3rd officer, and saloon steward Walter Nichols. What these men had experienced that night was horrendous, and they had seen with their own eyes Titanic take her dying plunge. Now they were about to see it again. They stepped into the Odeon Theatre in London, and the projector fired up to premiere A Night to Remember to the world. It's a question I get asked a lot. Did any Titanic survivors see any of the movies, and if so, what did they think? Well, the answer is yes. Quite a few experienced the various movies made about Titanic, and the historical record has fortunately recorded their reactions, and some might surprise you. From the appalled and the offended, to the content and proud, and even one survivor who had to be prevented from joining on as an extra to experience the sinking all over again. Thanks to research of historians and some fine articles over at Encyclopedia Titanica, today we'll explore the reactions of Titanic survivors to the movies and see how accurately Hollywood portrayed the story. Chances are you've seen a movie about the Titanic at some point. A few people avoid the most famous one like the plague purely because it was so popular, but the fact is that Titanic movies have been enthralling audiences since the very year the ship sank. Now, this story probably needs to begin in about May 1912, in the immediate aftermath of the Titanic disaster. Now, the news had shocked the world and become one of the first true smash global news stories, and naturally it generated an insatiable appetite for souvenirs, merchandise, and that newfangled entertainment media, the silent moving picture. Now, there was just one problem with this. Newsreel cameramen hadn't really bothered to film Titanic at all. The ship was so identical in exterior appearance to her sister ship Olympic that footage of the latter was modified to just pass it off as the genuine article. It helped that Titanic's lost captain, Edward Smith, had also skippered Olympic for her inaugural season, so this newsreel was shown to fascinated audiences and presented as Titanic. But the telltale sign that it had been faked are the tugboats. Their names in the port of registry have been scratched out frame by frame, because they would have said New York. And that's where this bit of footage of Olympic was shot. And of course, Titanic never made it to New York. It was a cruel and disingenuous trick, but it worked. Documentaries about Titanic actually continue to show this footage to this day. But it wasn't a movie in the real sense of the word, just recycled news footage. The race to output a film about the disaster was on, and it leads to probably one of the most bizarre sagas of the entire story. Dorothy Gibson was one of the first movie stars in an era where theatre performers were held in very high regard. At 22, she had boarded Titanic in first class and captivated the male passengers in particular, and on the night of the sinking she'd actually been up late playing bridge whist, and she, along with her mother and a party of some of the bridge whist players, had boarded the first lifeboat to leave the ship. Now, incredibly, almost as soon as she got back to New York, Gibson was attached to a production about the sinking, aiming to capitalise on that massive international interest in the disaster. The film has been lost to history, unfortunately, but we know a little bit about it. Now, it probably used that same Olympic footage to give an air of authenticity, because the same producer who'd made that infamous newsreel was behind the new movie. To give it a touch more realism, Gibson actually wore the outfit she had worn aboard the lifeboat when she had evacuated the ship. Saved from the Titanic was released less than a month after Titanic had sunk, and in fact, filming took just 1 week, making use of a derelict transport ship to stand in for the lost liner. The film was a smash hit, with sold-out viewings across the US, but reviews weren't all good. First was the obvious fact that the film was a soulless attempt at cashing in on the disaster while the bodies of victims were still being recovered at sea. So what did survivors think of the film? Well, first there's Gibson herself, and while she may appear to have been a willing participant, it seems that the truth is a little bit more uncomfortable, that she may have been manipulated or pressured into it by the producer with whom she was having an affair. Now, throughout the production, Gibson's nerves were shot. She openly wept in the middle of filming. Her discomfort did not go unnoticed. One reviewer said that Gibson had the appearance of one whose nerves had been greatly shocked. Another reviewer called out the blatant exploitation, saying, "The bare idea of undertaking to reproduce in a studio, no matter how well equipped, or by reenacted sea scenes an event of the appalling character of the Titanic disaster with its 1,600 victims, is revolting, especially at this time when the horrors of the event are so fresh in mind, and that a young woman who came so lately with her good mother safely through the distressing scenes can now bring herself to commercialise her good fortune by the grace of God is past understanding." Now, what other survivors thought of this film is sadly lost to history, but maybe the reaction can be gauged by what happened to Gibson next, because she actually quit the movie business for good, and Saved from the Titanic became her last ever picture. Now, it wouldn't be until about the 1950s that any serious or worthwhile attempt was made at depicting the Titanic disaster on film again. By then, most of Titanic's survivors were now already elderly, but the passage of time brought some convenient factors for filmmakers. For one, many survivors were, over 40 years after the event, now ready to talk about their experiences. Researchers like Walter Lord were conducting more in-depth research about the disaster. Lord would release his findings in the best-selling book A Night to Remember in 1955. But 2 years earlier, in 1953, the first major Hollywood movie about Titanic was released, and many survivors from the real disaster jumped at the opportunity to go see it. The film, appropriately named Titanic, was released in 1953 to much acclaim, and it boasted a star-studded cast. But the film, objectively, was not that great. It was full of inaccuracies which will frustrate any serious Titanic nerd. For example, throughout the entire sinking, an annoying alarm blasts almost non-stop, which of course just didn't happen in real life. But given the scarcity of serious research done on the disaster and the fact that this was Hollywood's first attempt at depicting it, the effect was enthralling. Of course, newspapers rushed to interview survivors who had seen it, and fortunately, quite a few did. Eugene Daly had been a young third-class passenger aboard Titanic, and his survival was remarkable for the fact that so few passengers of his demographic actually made it off the ship alive. He had made himself known around the ship for his playing of the pipes as the vessel left his native Ireland. He tried to board one lifeboat early on in the sinking, but was forcefully pulled out of it, and in the end he narrowly escaped the sinking ship by helping free one of the collapsible boats from the ship's officers' quarters roof, climbing in from the freezing water after the boat had floated free of the wreck. When Titanic came out in 1953, Daly was then 72. He was quite complimentary of the film, saying that the producers had done a fine job of reproducing the feeling of the night, given they hadn't experienced it themselves. He liked it so much, in fact, that he went to go see it a second time, although he did criticise the lack of likeness between actor Brian Aherne and his character Captain Smith. Daly was especially touched by the depiction of Catholic priests offering absolution as the ship sank, something he said was one of the last sights he'd taken in from aboard the liner. Now, other survivors' reactions to the 1953 Titanic film were mixed at best. Actually, it's really an interesting depiction of the wide variety of testimonies that often conflict from the night's event itself, and demonstrate at least a little bit why eyewitnesses can sometimes be a little bit unreliable. Anna Nisten had been another third-class passenger, aged just 22. After the disaster, she often suffered nightmares, but in 1953 she overcame her trauma and went to go see the film. She cried all the way through it, and afterwards she said, "I wanted to see the picture, still not. I would not feel good if I didn't, but I cried. I remembered some things. The picture was wonderfully done." Another survivor was Bertha Moran, also from third class. As she watched the film, and the lifeboats were lowered away, she exclaimed, "It was just like that." She thought the movie was very good, even though reliving the memory of it must have been traumatizing since she had lost her brother in the sinking. Addie Wells was a second-class passenger aboard the ship. Of the movie, she said, "I don't see how those movie people got the scenery to look so real." She said it looked just like the Titanic as I remembered it. Other survivors were less enthusiastic about the movie. Percy Oxenham had been a second-class passenger aboard the ship who, after surviving, joked that he wouldn't return to England unless a bridge was built across the Atlantic. He criticised the 1953 movie, first for the depiction of the orchestra playing their instruments right to the end. He said, "There was no band playing accompaniment to Nearer My God to Thee. It was impossible to play because all the instruments were below in the quarters and the hatches were battened down." Now, this is an unfair criticism because although Oxenham might not have heard or seen the band, we know, of course, that they did actually play their instruments throughout the sinking, but his next point is a fair one. He pointed out that John Jacob Astor, Titanic's richest passenger, is depicted as selflessly giving up his spot in a boat for a woman with a baby, but in reality Astor had actually asked to join his wife in a lifeboat, but was refused, so he simply stepped back. Jack Ryson, who'd been travelling with his family in first class, simply said that the movie was, quote, "not real." Interestingly, other survivors criticised the movie for being too depressing in its realistic representation of the ship's sinking, which when you think about it is probably more of a compliment to the film's production qualities given the circumstances. Survivors Leah Axe and Selena Cook watched the film together and it brought them to tears. Leah described it as depressingly realistic, a strange contrast to Cook, who called it good entertainment for everyone. Addie Wells, who had previously commented on the realistic sets and the special effects, agreed with Leah Axe when she called it terribly depressing. Now, plenty more survivors watched the film, but their reactions went unrecorded. Historical inaccuracies aside, obviously the opportunity to relive the events was a huge draw for many, either for closure, or as Selena Cook put it, for good entertainment. But nothing would come close to the hullabaloo just 5 years later, when Walter Lord's book was turned into a movie that still stands today as possibly the most accurate depiction of Titanic ever filmed. Incredibly, this time, surviving passengers, crew, and even the ship's own officers were brought in as consultants to help the accuracy and realism, and the results speak for themselves. A Night to Remember is considered one of the greatest historical films of all time because it did so much to avoid the overdramatization and the sensationalism that had been attached to the Titanic story for nearly 50 years since it sank. Walter Lord's book cut through the rubbish thanks to his exhaustive research. Now, fortunately, it meant that when it came time to make the film, the survivors he had interviewed already for the book and become friends with were eager to put their hands up to help with the film. And to the filmmaker's credits, the producers were keen to oblige. Now, chief among the consultants for the movie was Joseph Boxall. He had played a pivotal role in the voyage, the sinking, and the evacuation because he'd been Titanic's fourth officer. Titanic's sinking had been a source of despair to Boxall ever since. He had barely spoken of it, so family and friends were actually surprised when he agreed to serve as a consultant on the film. Boxall was naturally a quiet and reserved man. On the night of the sinking, he, as one of the junior officers, was on duty and made it to the bridge just after the collision. He performed an inspection of the damage and then, famously, was tasked with calculating the ship's position for distress calls to be sent on. His position was about 15 miles, or 30 kilometres, too far northwest of the real disaster site, but it was close enough so that the rescue ship Carpathia made it to pick up survivors just a few hours later. Now, this wasn't really an indictment of his seamanship, because Captain Smith himself also made an incorrect calculation that was even more wrong. It could have been due to the bizarre atmospheric conditions which messed with the size and the brightness of stars in the sky, despite the clarity of the evening. Boxall had escaped the sinking ship about half an hour before she took her final plunge, and when he finally stepped aboard Carpathia the next morning, his voice had broken with emotion as he reported to the rescue ship's captain just what had happened. The experience didn't kill his enthusiasm for the sea. In fact, he went on to serve aboard Titanic's sister ship Olympic, but he always was reluctant to recall the disaster that he had experienced. When he first found out about A Night to Remember, he was not impressed, and he wasn't keen on taking part in the production. But slowly, he was persuaded, thanks in part to his friend Commodore Harry Grattage, who had commanded many famous liners himself. After 2 months of back and forth, Boxall agreed to help, saying it was his duty to, quote, see the old ship sink properly. Now, it might have started off reluctantly, but in the end, his involvement with the film became a real source of closure to Boxall, who found a new lease on life because of it. Originally, he said he wouldn't even leave his home in Christchurch, but footage shows him walking wistfully around the A Night to Remember set. Of the production, he said, I have a great admiration for those film chaps who had to endure each shot being taken 3 times over in the cold October whilst floundering about in Ruislip Reservoir. Boxall attended the premiere of the film in 1958, and sadly his deeper thoughts on the film weren't ever made public. He said he was pleased with the result and impressed by the amount of money actually spent on the film. But fortunately, we have this one fascinating photo of Boxall sat watching the film by himself. What he was thinking as he relived the events of that night will of course never be known, but it's definitely captivating. Now, Joseph Boxall wasn't the only senior crew member to see the film. Herbert Pittman had been Titanic's 3rd officer. He watched the movie at the premiere with his old colleague Boxall, and he said, the film is an excellent representation of what happened, and I can't recall a single technical mistake. Sylvia Lightoller was the widow of 2nd Officer Charles Lightoller, portrayed by the star of the film, Kenneth More. In fact, Sylvia is seen here being kissed by Moore in this rare newsreel film. She'd been a consultant on the movie too. In fact, she was portrayed early on in the movie. She was glowing in her praise for Moore's portrayal of her husband and said the film is really the truth and has not been embroidered. There's no doubt that Lightoller, who died just a few years earlier, would probably have leapt at the opportunity to help out on the project too. Now, another visitor to the A Night to Remember set was Edith Russell née Rosenbaum. She's one of those Titanic characters that is just so memorable. She was very spirited and extremely forthright. She'd travelled first class and tried to take insurance out on her large numbers of trunks and belongings, but she said she was told that since Titanic was virtually unsinkable, it was unnecessary. Now, on the night of the sinking, she said she'd actually seen the iceberg slip past her stateroom window as she was getting undressed. She quickly reported to the lifeboat stations up on the boat deck. Now, later on, she sent her steward back to her stateroom to retrieve a prized possession of hers, which was a little musical toy pig. Edith went on to become an accomplished journalist and even reported from the front lines of the First World War. But she was never afraid to discuss her experience of the Titanic sinking, and since she was being portrayed in A Night to Remember, she was invited to the set, and what she saw left a big impression. The film's producer, William McQuitty, toured her around, and the normally talkative Russell was left stunned. She stood quiet for a while, staring at the set, about a third of the ship's boat deck with 2 towering funnels and all the lifeboats on their davits. I can't believe it, she said. It was here that I stood. Once the film was released, Russell quickly set about watching it, and she actually had mixed feedback. She said Captain Smith is perfect, also the set and the gala dinner, the dining room, perfect. But they make me push my jewellery aside and take the pig from the stateroom, all different from fact, and it's a factual film. Now, probably one of the most touching reactions from any of those visiting the set was from Helen Melville Smith, who was actually Captain Smith's daughter. She'd been just 14 years old when her father had died with Titanic, and surviving letters portray Smith as a caring and devoted father. When Helen visited the set, she came face to face with Lawrence Naismith, who was actually playing her father, and she was understandably emotional about the whole experience. Now, one of the more funny stories concerning the production of A Night to Remember involves the survivor Lawrence Beasley. Now, he had actually boarded as a second-class passenger, In fact, he makes a small cameo in one of the more famous shots taken aboard the ship up in the gymnasium for first class. Now, unlike some others, he was not reluctant to discuss the disaster. In fact, he published a memoir just 9 weeks after the sinking. When he got wind of the A Night to Remember production in 1957, the 80-year-old took it upon himself to gatecrash the production by sneaking onto the set dressed in period-correct 1912 clothing. There, a section of the boat deck had been recreated for scenes of the final plunge, and Beasley was apparently keen to go down with the ship once again. But at the last moment, before cameras started rolling, he was spotted and the game was up. Ostensibly because of actors' union rules, but also probably because subjecting an 80-year-old to freezing water in a sloping deck was inadvisable, Beasley was asked to leave the set. Quite a few passengers watched A Night to Remember, possibly because its reputation as an accurate portrayal and the fact that consultants had been used began to spread throughout the remaining survivors and the public as a whole, only adding to its appeal. Amazing insights came in from survivors all over the world. Richard Norris Williams had been a first-class passenger and a budding tennis player. He had actually travelled with his father, and on the night of the sinking, the pair had stayed on the ship until the last minute. They were part of the mob struggling around the collapsible lifeboats at the first funnel. Then that collapsing funnel had only just missed Richard, who looked on astonished as it crashed right down on top of his father and many more. He was pulled from the water, but his time in the freezing cold had taken a huge toll. His legs likely needed amputation thanks to the frostbite, but Norris refused. He overcame his condition and went on to become an accomplished tennis star, winning competitions even from 1912. He watched the film and said that it was restrained in its realism, but vivid in its portrayal. I could just visualize it happening again. In particular, the scenes of the collapsing funnel was something he described as chilling. Even Lawrence Beasley, who tried to sneak into the set, got to watch the film, and fortunately his actual response was captured by news cameras.
I thought it was most extraordinary. I had no idea that the realism could be produced in such a wonderful fashion.
Others were brought to emotion by the film. Gretchen Longley had been in first class, and she said, "I just had to cry as I kept thinking of that beautiful ship and all those wonderful people. I was returning from Europe with my 2 aunts. I refused the one remaining spot in the 3rd lifeboat to remain with them, but we found room in the 4th boat." Now, some of the feedback was highly positive. Writer May Futrell had lost her husband, the author and journalist Jacques Futrell, in the sinking. Obviously, the anticipation for the film's release was great. She was asked afterwards what she thought, and she said, "If you'd asked me that the first time I saw it, I couldn't have told you because I was too upset. But after the second showing, I can tell you I believe it to be remarkably accurate, honest, and an exciting film. More inaccurate nonsense has been written about the Titanic than I have time to tell you, but speaking for the portions of that picture that relate to my own experiences and to what I saw and heard, I can only tell you this is the way it happened. I was there, and I know." But the sad truth is that the vast majority of survivors who watched A Night to Remember found the experience to just be too emotionally exhausting. Renee Harris, the theatre manager and producer, had been travelling first class with her husband. When she boarded a lifeboat, she had actually jumped out of it, so desperate was she to stay with him, but she was finally evacuated just before the ship's final plunge, while her husband, Henry, remained behind and was lost. 46 years later, the pain was still too much. "I'm afraid I'm a sissy," she said. "I couldn't get myself to attend the premiere, but submitted to viewing it privately. I only watched the very beginning. It was so realistic. I couldn't take it." In fact, at a special screening of the film before its general release, she had walked out of the theatre. "I will never see the rest of this," she said. "It carried me too realistically back to that night." She later said, "It was a night to forget." Now, the same was true of 2 other survivors, Anna Bolton and Eva Hart. Anna said simply that when the boat started to sink, "I left." Eva had been just 7 years old when she boarded Titanic, but the memories were still fresh and vivid. She reflected on A Night to Remember when she said, "My personal feelings were mixed. I thought and still think it a really marvellous film, one which I doubt can be bettered, but there are 1 or 2 scenes of the actual sinking which I couldn't bear to watch. Although I've seen it many times, I still close my eyes when these come on the screen." Now, one survivor reaction to the film is particularly moving, even without any recorded verbal testimony. Emma Bliss was a stewardess aboard the ship. In 1958, she was in her 90s, and she watched the film, emotionally supported by her nurse, Her thoughts weren't recorded, but a series of photographs from the viewing show her simply breaking down at the side of the sinking. Now naturally, with the passage of time, the number of Titanic survivors began to dwindle as they passed on. And by the time the 70s and the 80s and the 90s came around, when the next batch of Titanic films were ready for production, there were precious few people left who could actually remember the night of the sinking. In 1997, James Cameron's Titanic was released to global acclaim. Naturally, it sparked a huge revival in interest in the Titanic story, and there was a mad dash to secure the thoughts of survivors. The only issue was that there were very few left. Eleanor Johnson had been just 2 years old aboard Titanic, and her survival was remarkable as well because so few children from third class had ever made it off alive. In fact, survival rates were around 40% or less. Of course, she couldn't really remember the events of the night, but she had vague recollections of being cramped into a lifeboat in her mother's arms and the screams of people around her. Eleanor was moved by the film, but enjoyed it nonetheless. In fact, she actually watched it 2 times and particularly enjoyed the opening scenes of the ship on the ocean floor. Other parts she found difficult to watch. "I did a lot of crying," she said. Milvina Dean was the last living survivor of the wreck, and her opinion of the movies was straightforward. She'd been just a child aboard Titanic too, but the disaster had left a lasting impact because she lost her father in the sinking. Watching A Night to Remember in the 50s had brought nightmares, and in 1997 she outright refused to watch James Cameron's film. To her, it was all too real. The Titanic was a tragedy which tore so many families apart, she said. "I lost my father, and he lies on that wreck. I think it is disrespectful to make entertainment of such a tragedy." In May 2009, Milvina Dean passed away at 97 years of age, bringing to an end the living memory of Titanic. Now, all we can do is rely on testimony and research to bring that fateful evening to life. But fortunately, thanks to newspaper reports and rare interviews, we have an idea of what many Titanic survivors thought of the disaster in the years since, and their reaction to Hollywood's attempts at recreating it. Ladies and gentlemen, it's your friend Mike Brady from Oceanliner Designs. Thank you so much for watching this video. If you enjoyed it, please leave a comment below. And don't forget to subscribe to the channel because we get new videos out weekly. If you want to support my work and get really cool perks like behind the scenes and early access, please visit my Patreon in the link in the description below, or sign up as a YouTube member. Come and join the crew. And as always, stay safe, stay happy, and I'll see you again next time. In July 1959, a beautiful ocean liner with a slick white hull and a tall, buff funnel glid smoothly into Melbourne Station Pier. And this wasn't just any ship, it was the RMS Strathnaver. And she's really important to me and my family because on board that ship, of all the hundreds of immigrant families, there was one little one that contained my grandparents, my father, and my auntie. But Strathnaver was important for a huge number of other reasons, because when she was first introduced in 1931, she represented a huge technological step forward for her owners, the P&O line, and completely changed the way that they would build and operate ships into the future, and here's why. Today, P&O is a household name in the cruising industry, but some would be interested to know that you can trace the line's history all the way back to 1822. From the mid-19th century and into the 20th, it came to dominate many of the world's passenger and cargo shipping lanes, with an expansive fleet of ships so ubiquitous that by 1910 it would have been difficult to find a port in the Far East which did not have a P&O liner with its stark black funnels tied up or at anchor. Their empire spanned the globe, a perfect mirror image of the influence of the British Empire itself. Wherever Britons needed to go, P&O would take them there. For decades, P&O liners looked like this. So, how did the company end up with a ship looking like Strathnaver? P&O had built an empire on tradition. Their ships were solid, built by some of the greatest shipbuilders of the era, like the famous Harland and Wolff shipyard. But in the First World War, the company took a massive hit, losing no fewer than 85 ships to enemy action. Coming into the 1920s, the company needed to drastically rebuild its fleet. So to do it, they turned to a formula which had always worked for them. Steady, reliable ships with stuffy, timber-clad interiors. P&O's mantra was a little bit like, if it ain't broke, don't fix it. So right out of the gate after the First World War, P&O puts in an order for two near-identical sister ships intended for the Australia run, Multan and Maloja. Externally, these two sisters looked really similar to P&O's first Multan and Maloja of 1905 and 1910 respectively. This set the pattern for P&O into the 1920s, classic-looking liners with black hulls, black funnels, and superstructures painted a lovely drab colour, which the P&O line executives called stone. Their ships mostly ignored fancy turbine engines for the rugged and reliable expansion steam engine, which had powered their ships since the 19th century. They wouldn't be breaking any speed records, but they didn't need to. They would chug along at the nice, happy speed of 15 knots. Smoking rooms were out of bounds to women still, and P&O ships carried twice as many first class as second class passengers, just as they always had. All was right with the world. But then there came a shock. The world had changed. The Edwardian era had given way to the Jazz Age. Art Deco was chic. Timber-clad Edwardian smoking rooms were antiquated. Everything about P&O's entire fleet screamed outdated. The dark paint scheme had originally been completely practical. During bunkering or refueling, the coal-fired ships would get absolutely covered in coal dust, and their funnels would slowly blacken thanks to the soot from the smoke. Keeping everything a dark colour would obviously hide the muck, but by the 1920s, ships had become oil-fired. They didn't require the arduous coal bunkering process anymore. So therefore, P&O ships didn't need to be dark and drab. Although the P&O line basically ran a monopoly on many Far Eastern routes after it had assumed control of the British India Steam Company, and also had a majority stake in its chief rival, the Orient Line, the fleet looked old and a little bit sad. Something drastic needed to be done, so P&O's chairman, Lord Inchcape, thought about the conundrum and came up with a plan. It called for a pair of ships the likes of which the world had never really seen before. They would be named Strathnaver and Strathnaver. Everything about these two near-identical sister ships would be revolutionary for P&O Line. First and most obviously was the exterior design. Visually, the ships were huge, but at about 22,000 gross registered tons, they were not a massive size upgrade over preceding liners on the Australian run, like Multan, which came in at 20,000 gross registered tons. They just looked bigger and more powerful, because instead of following the traditional lines of an Edwardian liner, low, sleek, and with little superstructure above the hull, Strathnaver and Strathnaver were tall, and they had huge, towering superstructures that made them look solid. Instead of the older, tall, narrow funnels, Vickers Armstrong, the shipbuilders, had opted for 3 squat round funnels, 2 of which were actually dummies intended to balance out the exterior. Because the 2 ships would be oil-fired, they only needed 1 funnel to vent the fumes. But there was another huge advantage here. The ships would no longer need to be painted black. Instead, P&O went for a dramatic change. The ships would be painted all white, with beautiful buff funnels and masts. Just look at this comparison. Here is what Strathnaver would have looked like if she was painted in the traditional way, and here is how she looked in her smart new getup. Yeah, it's a pretty big difference. On the inside too, Strathnaver set an absolutely marvellous new standard of luxury for the England to Australia run. Long gone were the dark, stuffy smoking rooms, and in their place were lush lounges thickly carpeted with beautiful Art Deco artwork and furniture. First class was downsized, and on introduction, there was actually no third class. Instead, much of the ship's accommodation was taken up by the new tourist class to reflect the growing size of the population, which today we refer to as middle class. For the first time in history, people who weren't super rich had means to travel, and so on Strathnaver, they could do it in style and comfort. They had access to lounges, libraries, and nurseries for the children, all beautifully decorated and very smart. To emphasise the point, Lord Inchcape directed that even the menus and printed material would showcase gorgeous Art Deco scenes and drive home that Strathnaver was a new ship for a new era. But wait, now in my hands, I'm holding a book. That's not just any book. This was actually printed for the operators of Strathnaver and Strathnaver and possibly even kept down in the engine rooms. And when you open it up, like I did for the first time, you might be a bit disappointed to not see any cool illustrations of engines or turbines. But no, the focus is on electric circuits and generators. The real secret to Strathnaver's revolutionary approach lay down in the engine room, because instead of plodding expansion steam engines, which, albeit were reliable, there was a set of fancy new turbo-electric engines in their place. Instead of driving the propellers directly, the turbines generated electricity, and then electric motors powered the propellers. This meant that you could control the speed of the propellers without need for a complex, fragile gearbox, while also providing enough electricity to power all the ship's lights, all the communication systems, and everything else. P&O had actually tested this on the Viceroy of India, which was built only 2 or 3 years before Strathnaver's introduction, but from the outside you just couldn't tell it, because it looked so old. Older P&O ships, like Multan of 1919, put an emphasis on cargo carrying, meaning the ships were covered in cranes and booms. Multan had no fewer than 16 of these huge hydraulic cranes which towered over the boat deck. But Strathnaver and Strathaird prioritised passenger capacity over cargo. Strathnaver would carry 1,170 passengers to Multan's 660. This meant that instead of towering cargo handling machinery cluttering the decks, Strathnaver's decks were clean and open, and they featured deck tennis courts and even a veranda cafe for tourist class with stylish wicker furniture. Lastly, even the name was a break from tradition for P&O. Previously, their liners were named for cities in the colony, like Chitral, Multan, Medina, Narkunda, and so on. This was decidedly colonial and a holdover from the 19th century. Instead, Strathnaver was named for Lord Inchcape himself, who was an Earl of Strathnaver in Sutherland, Scotland. Strathnaver was finished in 1931 and sailed on her maiden voyage, but it wasn't without incident. For efficiency, the ship was fitted with propellers that turned inward and not outward, as was tradition. This had an adverse effect on manoeuvrability, and the ship proved to be a little bit of a handful at first. She even ran aground briefly in the Suez Canal. This was later rectified with no noticeable effect on the engine efficiency. Another small problem that was never really solved was more cosmetic, and it involved the funnels. Of course, only the center funnel was operational, so the oil smoke slowly turned the top of that funnel black and grimy, while the other 2 funnels remained pristine, which gave away the illusion somewhat. Despite these little teething troubles, Strathnaver was met with absolute enthusiasm by the public. So much so that, even in the face of the Great Depression, P&O went on to complete the sister ship Strathaird in 1932, and then order 3 running mates through the rest of the 1930s, named Strathmore, Strathallan, and then Stratheden. Each was progressively bigger than Strathnaver, but obviously built to the same standard which that ship had set, featuring a smart white hull, buff funnels, and slick Art Deco interiors. All of these ships would have fascinating careers, and I'll probably do a video on each at some point, but suffice it to say that P&O's gamble was an absolute success, and from then on, all new ships would follow the precedent set by Strathnaver in 1931. And to this day, P&O ships feature smart, white hulls. The last black-hulled P&O liners in service, Multan and Maloja, were retired and scrapped in 1954. Strathnaver herself had a very long career, serving during the Second World War as a troopship and finally as a single-class immigrant liner in the 1950s, which is when she carried my family to Australia, which is also why I have the accent that I do. Thanks a lot, Strathnaver. Most famous shipping disasters have happened out of sight, under cover of darkness like that of Titanic, or in a raging storm. The simple truth is that for hundreds of years, humans have taken to the ocean in ships, but the camera is a relatively recent development. Before the camera, it was up to painters and artists to recreate how disasters at sea might have looked. But nowadays, people can play witness to real events without having to actually be there, and the result is chilling. From the results of dramatic collisions, the aftermath of deadly storms, or the dramatic rescue of people from burning ships. I said in a video once that as long as ships have existed, there have naturally been things for ships to run into, and obviously, one of those things is other ships. The results can be extraordinarily deadly, as we explored in our video of the Empress of Ireland, but sometimes the conditions are just right and lives can be saved. Fortunately, the results of one such collision were actually filmed back in 1914, and it's really dramatic stuff. The SS Iowan was a small steamer built in 1912, some 6,500 registered tons and just over 407 feet or 124 metres in length. No giant by any means, but a steady, reliable ship in a class of 8, each named for a US state. They would link the US mainland and Hawaii, regularly ferrying out refrigerated cargo from the west coast. Her early career was fairly straightforward, using her 490,000 cubic feet of storage space to ship exotic goods like pineapples and sugars back from Hawaii. But then, the most dramatic thing happened in October 1914. This time, the ship was steaming out of New York, since the Panama Canal had opened, allowing trade with the eastern seaboard as well. Iowan was steaming at a decent clip through the entrance of the Ambrose Channel, the dense sea lane that leads into New York and New Jersey. Now, this is a tightly packed, busy bit of water, only 5.8 miles or 9.5 kilometers across at the entrance. Now, that might sound big to us landlubbers, but to a ship's crew, it's almost as narrow as it gets, with little margin for error. You can only imagine how tough it would be to navigate if you couldn't see ahead. Well, that October day, as Iowan steamed through the channel for open ocean at speed, a dense cloud of fog had rolled in and totally obscured visibility. Now, in situations like this, it was considered the best thing for ships to slow right down, but to continue moving ahead to maintain something called steerage way, which is just enough water rushing over the rudder to ensure that the ship could actually turn. Now, at a dead stop, a ship is effectively uncontrollable, and it could easily drift into a lee shore, that is, nearby coastline, in the direction that the wind is blowing. Now, Iowan's skipper, Captain R. Pearson, didn't seem to slow down a bit. Instead, he set about customarily blasting his whistles at intervals to warn of his approach. But then, out of the fog ahead, there loomed another ship. It was the small passenger steamer SS Metapan. Metapan was a combination cargo passenger liner run by the United Fruit Company, about 3,000 tons smaller than Iowan. The ship was entering the channel for New York loaded with fruit and South and Central American passengers, but unlike Iowan, she was actually stopped dead in her tracks, waiting for the fog to pass. With 300 yards or 250 meters between them, a collision should have been totally avoidable. Metapan blasted her whistles, but Iowan kept on coming, seeming to ignore the danger. With no attempt made to change course, Iowan simply dropped her anchors in an attempt to slow down, and with a deep crunch and a lurch, the two ships collided. Iowan sank her bow about halfway through the Metapan's forward hull, and with the force of the collision, the two ships were separated and lost again in the fog. Metapan's skipper now had to act quickly. With tons and tons of water now roaring in, he rushed his ship for the shallow channel bank to beach it and prevent it from totally sinking, got his lifeboats ready and lowered his passengers away. With a sickening lurch, Metapan struck the bottom of the channel and stuck fast while her stern was comically lifted clear of the water. Now, the result was a pathetic sight, with Metapan half sunken and resting on the bottom with a huge gouge taken out of her bow. Fortunately, the evacuation was perfectly executed and without casualties, but this remarkable bit of footage was taken from rescue and survey vessels showing the extent of the damage and the poor old Metapan frozen in place on the channel bank. Now, this is a fairly obscure event, so I haven't been able to track down the results of the accident, but passengers and crew blamed Iowan for not slowing down or changing course when the ships had spotted one another. Iowan's bow was crushed, but she was returned to service and went on to become a troop transport and cargo vessel which served successfully in both world wars, but the Metapan was patched and refloated and eventually sunk by a mine without casualties in the Second World War. But this time her sinking was for good. Sadly though, not all maritime incidents are as relatively harmless as that of the Iowan and the Metapan. Captured on film in 1954 is the overturned hull of a Japanese ferry, the ship called Toya Maru, and this is one of the worst peacetime maritime disasters of all time. Toya Maru was built in 1947, part of an effort to rebuild Japan's merchant fleet. Japan's navy had been simply shattered by the Second World War. In fact, of all the nation's dozens and dozens of big passenger ships from before the war, only 2 had survived, including the Hikawa Maru, which is today moored in Yokohama as a museum ship. Toya Maru was no giant, but she was new and she was modern, almost 4,000 registered tons and 390 feet, or 119 meters long. Now, the ship was a ferry designed to link a railhead between Japan's 2 main islands, from Aomori and Hakodate. It was a 4.5-hour trip, 55 kilometers, or 33 miles of which would be through the Tsugaru Strait. Now, Toyomaru was a new style of ferry, the roll-on, roll-off ferry, which we've covered on this channel before. Suffice it to say, this style of ship had a bit of a troubled beginning, because they relied on cars being able to drive straight into the hull, resulting in poor watertight subdivisioning, allowing easy access, and huge doors that were a natural Achilles heel in the design. Now, the Tsugaru Strait is a particularly rough bit of water, essentially an open sea, given the nickname of the woman who calls the storm. And in 1954, 7 years into Toyomaru's career, the strait would live up to that moniker with deadly accuracy. Japan's typhoons are wild, raging storms that roar in, causing devastation. But they are not short-lived events. Rather, they tend to hang and mope around, sometimes blowing over the mainland, and other times swinging wildly out to sea. Typhoon Marie had smashed through the main island of Honshu in September 1954, and then lay offshore in the Sea of Japan. Toyomaru was maintaining her usual busy schedule, an important one given the need to link the two main Japanese islands, but on September 26th, her departure from Hakodate was delayed as her captain observed and predicted the path of the typhoon. It was predicted to hit the Tsugaru Strait and blow clean through sometime around 5 PM. Now, another ferry's trip was cancelled entirely, so that ship's cars and passengers were instead loaded aboard Toyomaru as well, and the ship sat waiting for a chance to cross all day. Hours later, at 5 PM, the weather had begun to clear as predicted, and Toyomaru's captain assumed the typhoon had passed safely through the area. The ferry completed loading, made steam and set off for Aomori, but tragically, Toyomaru's captain was misinformed. Typhoon Marie had somehow picked up strength and power in its time through the Sea of Japan, which was unusual. It was now an extratropical cyclone with winds howling through at incredible speeds. It hadn't cleared the strait at all, and instead it was going to remain in place an entire day. Toyomaru was going to steam right into the heart of it. Sure enough, conditions got gradually worse. With the wind picking up, the ferry's captain must have realised his mistake. Less than half an hour after leaving, he decided to wait for the typhoon to calm and anchor his ship near Hakodate port where they had just left, which was a simple enough manoeuvre in calm weather, but a tall order in a storm. The anchor didn't hold, and the ferry slipped away, drifting at the storm's mercy. Those big doors designed to allow cars conveniently into the ship now began to take on tons of water, and they would prove to be Toyomaru's undoing. Her machine space is flooded, her engines died, and she was soon completely without any power or any control. For 3 hours, the ship was battered about by wind and huge seas until she finally came to rest at 10:30 PM, aground off Nanae Beach, only 4 kilometers, or just shy of 3 miles backwards from where she'd set out hours earlier. With monstrous, strong waves battering the ship's hull, the danger was plain. Although the town of Hakodate was agonizingly close by, the shore was just 100 meters away, the ship was stuck in the shallows and gradually being thrown over onto her side. Just 15 minutes or so after grounding, Toyomaru was capsized and flooded quickly. The ship's lifeboats broke their lines and were washed clean away, along with tons of equipment and flotsam. For those on board, escape and survival was a tragic matter of simple luck. There were around 1,300 people on board, and the next day it had become clear that just 150 had survived. This remarkable footage shows Toyomaru capsized in the relatively shallow water, the ship's underside pointed at the sky, while meanwhile the Nanae beach was littered with debris including the ship's boats and a life preserver. A party of 35 American GIs, artillerymen from the 1st Cavalry Division, had been aboard, and only one survived because he was luckily swept out of the ship's hull through an open porthole. Toyomaru wasn't just the only casualty of Typhoon Marie. 4 other ferries were sunk and many other ships were beached, like this cargo vessel which is lying less than 100 meters away from the Toyomaru's overturned hull. In the end, the rough state of the Tsugaru Strait and the frequency of bad storms expedited the construction of a tunnel, the Seikan Tunnel, which today operates a high-speed Shinkansen service spanning some 14.5 miles, or 23.3 kilometers under the sea, and the dangerous woman who calls the storm. Of course, huge storms are not just unique to Japan. Massive seas have taken down ships across the globe, and in 1960, a huge North Atlantic storm broke a tanker clean in half. Pine Ridge was a tanker built for the US Merchant Navy during the Second World War, a time of booming industry for the nation as it rushed to output as many ships as possible. In the end, America's shipyards built an incredible 6,000 odd hulls in just 5 years of wartime as part of the emergency shipbuilding program. Now, the speed at which these ships could be constructed is incredibly impressive. In fact, a full Liberty ship, some 7,000 registered tons and 441 feet long, could be launched just 24 days after the keel was laid. But with the rush of increased output came some serious quality control issues. The quickly employed workforce lacked years of welding experience, and the result was often poor weld seams that were prone to cracking under extreme stresses. Now, this might not be an issue if the ships were designed to mitigate cracks or at least control them to radiate them away from vital sections of the ship's structure, but big open shafts like cargo hatches with their sharp squared corners became a natural stress and failure point, and this was not accounted for in the ship's design. And on top of all of this was the quality of steel. That used at the time was fairly brittle by today's standards. Back in December on this channel, we examined the story of the steamer Schenectady, which had snapped cleanly in two while she was tied up at her fitting out wharf. Throughout the war, there were 1,500 recorded examples of brittle hull fractures on the likes of Liberty ships, and 12 of those broke spontaneously in half. Now, the cause was attributed to something called the ductile brittle transition temperature, which is a certain point at which cold water can change steel's character from that of ductility, that is, being fairly flexible, to brittleness, more prone to cracking. Of course, the frigid North Atlantic Ocean was behind this, and subsequent ships were built with design changes to accommodate for it. But even so, ships built during the war exhibited some dangerous characteristics, especially in North Atlantic storms. Tankers like Pine Ridge were long and narrow. In tall waves and troughs, they could have monumental forces concentrated at their centres. In 1952, a storm had caught two World War II era tankers, SS Pendleton and Fort Mercer, which both broke apart and sank with the loss of a combined 14 lives. Well, years later, in 1960, it was SS Pine Ridge's turn. On a trip from New York to Corpus Christi in ballast, that is not loaded with her cargo of fuel, the tanker was caught in massive seas and wind. Off Cape Hatteras, the ship was battered and thrown around until finally it all became too much. With a disturbing crack and a huge groan, the ship was broken cleanly into two sections which quickly separated. The bow section, with 8 men, including the ship's captain, sank, and the men were lost in the storm. But curiously, the stern section's watertight bulkheads held up, and the 28 men aboard anxiously awaited rescue. After the dangerous conditions had died down, this incredible footage was taken, showing the weird side of Pine Ridge's decapitated stern section floating dead in the water. Fortunately, the majority of the ship's crew was rescued by the aircraft carrier USS Valley Forge. The ship's stern was found to be in a good state of seaworthiness and was towed slowly home at just 3 knots, eventually making it into Newport News shipyard with her flag flying at half-mast out of respect for her 8 lost men. The shipbuilders at Newport News got to work, and the stern was welded to numerous other components to make a real Frankenstein's monster of a ship. The forward bow section of the T2 tanker Redstone, and the midship section of the T3 tanker Sachem. The result was a new ship named Meadowbrook, which returned to service 2 years after the disaster to enjoy another 20-odd years at sea before scrapping in the 1980s. Finally, we'll return to the waters off of New Jersey, which is a real hotspot when it comes to maritime incidents and disasters. Here in 1934, passers-by and residents were drawn out in their thousands by the horrible sight of an ocean liner burning stem to stern on their doorsteps. Captured on camera for the world to see, the liner Morro Castle was a scorched and tangled wreck, almost within spitting distance of onlookers on the shore, and 137 of the vessel's passengers and crew were lost. How the Morro Castle came to be in such a sad state is a fascinating story that begins some 4 years earlier, in 1930, with her construction and launch. Built for the American Ward Line, Morro Castle was an intermediate passenger liner of 11,500 gross registered tons, with a 480-foot or 146-metre length, and turbo-electric propulsion that could drive her through the water at a steady 20 knots. With a capacity for around 490 passengers, Morro Castle was designed to quickly and efficiently carry holidaymakers and business people, mail and general cargo alike, to Cuba from the US mainland. The route was a popular and profitable one, so Morro Castle and her sister Orient were built with luxurious standards in mind, with 2 classes for passengers, featuring elaborate lounges, sumptuous cabins and clean, elegant public spaces. The ship was the latest thing in technology, equipped with direction-finding navigational systems, and eventually a gyro compass and echo-sounding equipment, making her a vessel ideal for navigating those difficult waterways on the approach to New York. Morro Castle was capable of making the voyage to Havana in under 60 hours. For 4 years, she had a happy career, doing well for her owners and providing American travelers the rare treat of enjoying a drink in public in lieu of Prohibition's alcohol restrictions. But all of that came to a crashing and dramatic end in September 1934, when the ship was making her return voyage to New York from Cuba. On September 5th, as the ship steamed away from Havana with 549 people on board, the weather began to turn, and by the 7th, as the ship was trundling along up the eastern US coast, heavy rain had rolled in, and big swells began to make Morro Castle pitch and roll. That night, the ship's captain, Robert Wilmot, had had his dinner inside his cabin, but crew and officers were shocked shortly afterwards when he suddenly died of a heart attack. It was an incredibly ill omen for the usually happy ship, and just a small portent of the horrors to come. Morro Castle's chief officer, William Worms, assumed command, and the ship continued on as the winds and the seas picked up. All seemed well as the ship approached the entrance to the channel that would take her to New York City, and with just 8 miles or 13 kilometers to go, at 2:50 AM on the morning of September 8th, a passenger complained to steward Daniel Campbell that he smelled smoke. They were in the smoking room at the time, but with not much else to do to pass the time, Campbell began to hunt for the source of the smell, and then, in the first-class writing room on B-deck, he spotted smoke pouring from out of a small locker that held paper, pens, and uniforms. Now, Campbell got hold of a nearby fire extinguisher and opened the locker to try to put the fire out, but instead, it surged with the influx of oxygen. By the time the bridge was made aware, several crewmen were throwing buckets of water into the locker to try to stop the blaze as passengers looked on. Alarmingly, the flames began to flicker down, out of the locker, and onto the carpet and the lush drapes of the writing room, rising up to the ceiling and beginning to rage out of control. Soon after, the room had to be evacuated, and as crewmen struggled with a fire hose and hydrant, the fire raged white hot. They couldn't know it at the time, but it was being fanned by the ship's comprehensive ventilation system, usually a blessing for ships operating in hot tropical climates, but up top, where the wind and heavy seas were raging, huge volumes of fresh air were being vented down to fan the flames. Morro Castle's elegant wood panels and sumptuous furnishings were gobbled up by the fire as it quickly spread, and by the time an indicator panel on the bridge lit up to show the presence of flames, it was already too late. As the fire spread throughout the ship, crews at fire hydrants and hoses were dismayed when their water pressure vanished because the system was overwhelmed by the sheer number of hoses in operation at the same time. With the ship burning out from under his feet, acting Captain Worms knew that he only had a little time to act. He wanted to beach his ship on the nearby Jersey shore, but soon the main switchboards throughout the vessel had been burnt out and the power cut out completely. Then the lines leading the ship's wheel and telemotor to the steering gear and rudders were burnt, and all control over the vessel and the huge swell was lost as well. Now lit brightly like a beacon in the dark, Morro Castle drifted and burned as passengers and crew desperately tried to get lifeboats over the side and away. Only 6 of her 12 boats could be launched against the terrible listing and rolling of the ship in those huge seas. The next day, at about 7:30 PM, New Jersey residents were stunned to see the hulk of Morro Castle wash up on their doorstep, still smouldering in the darkening evening light. The ship had burned completely through with such incredible speed that passengers had become cut off from escape and were forced to make a terrible decision: burn or jump. Swimming in those conditions was a near impossibility, but still, passengers and crew were forced to jump for their lives, leaving whatever clothes or possessions they had at the ship's stern railing. Morro Castle loomed large over the Asbury Park beach, and she smoked and hissed as the fire continued to glow hot. 135 passengers and crew were lost in the disaster from the complement of 549, a toll which could have been far higher were it not for a rescue effort from a handful of passenger ships and smaller boats which braved the big swells. This incredible footage was shot from the nearby town of Asbury Park, where the Morro Castle had beached herself. Thousands came out to see her, and camera crews captured terrifying footage of the charred corpse of this once proud ship. Now, Morro Castle deserves a much bigger and more comprehensive retelling, something I'm keen to do on this channel in the future. Suffice it to say, the subsequent inquiries and investigations have sparked well-founded conjecture and conspiracy theories ever since. How exactly a fire came to break out inside a locked cupboard in the middle of the night was, and still is, unknown, but the fire was eventually dismissed as something of an act of God. William Worms, the chief officer, and others were charged with negligence, but they had their charges thrown out on appeal. The details surrounding the events leading up to the fire, the captain's untimely and unexpected death, and the outbreak itself are murky and very ominous. Captain Wilmot had died after eating his dinner and complaining of stomach pains, but he'd also supposedly claimed earlier that some unnamed person on board the ship had meant him harm. Chief radio operator George Rogers was hailed as a hero of the disaster. He told investigators that his assistant was the likely culprit, but with a lack of evidence, the investigation met a dead end. Shockingly, years later, Rogers was involved in a bizarre plot when his commanding officer, Lieutenant Vincent Doyle, was blown up by a mysterious package. The investigation into this crime brought Rogers' criminal past to light, which included poisonings and a spate of mysterious fires. Now, Rogers got a 20-year sentence for the attack on Doyle, who survived, albeit with permanent disabilities, but he only served 4 years. He was later found guilty of the bludgeoning murder of an elderly couple, and he died in prison. Doyle maintained for years that he thought Rogers had set the fire aboard Morro Castle. Today, many think that Rogers was behind the Morro Castle's loss, but the fact is that all evidence was destroyed by the fire itself as it swept through the ship, fueled by that highly flammable interior decor, the glued timber and the shiny wooden veneers. The crew's handling of the fire was found to be incompetent, and it's largely to blame for the number of lives lost, although, in their defence, the outbreak of a blaze, in the middle of a storm at sea in the dead of night, is a difficult set of circumstances to work with. The idea of arson on the part of Rogers is an attractive one, but a former engineer also put forward the theory that the blaze was the result of overheated uptakes, those large pipes that funnel smoke from out of the ship's boilers and into the tall funnels. With the rush of fresh air thanks to the storm, it was, he thought, likely that the uptakes had overheated and glowed red hot, that the cabinet in the writing room was just close enough nearby to the uptakes and the fire was caused by the transfer of heat. Whatever the case may be, the Morro Castle remains as one of the most dramatic shipping disasters to take place off the US coast, and the remarkable image of the towering ship burned through looming high over the New Jersey beach is one that is difficult to forget.